So hello everyone and welcome to the Science in Practice conference on literacy in science. We are absolutely overwhelmed to be hosting this event today with so many science teachers attending, and we can't wait to see what this morning has to offer. So some of you may have attended one of our events before, some of you may be totally new to Science in Practice, and some of you may have followed us on Twitter. So I'm just going to start by giving a little introduction about what we are all about. So Johnny, if you can flick to the next slide. Thank you. So Science in Practice is a network formed by a committee of science teachers for science teachers. Our committee is made up of Hannah, Kieran, Johnny, and myself, who you can see on the slide here, and you can see down the side as well. So Kieran works at St Edmund Arrowsmith Catholic High School in Wigan, and he is the assistant head of science there. You may have attended the Seneca CPD in the summer, where Kieran spoke about booklets and his fantastic tests and folds that he recently shared on Twitter as well. Then we have Hannah, who is the science lead at a new school in Croydon called Ark Blake Academy. Hannah is the kind of driving force behind Science in Practice, and it was her original idea back at the start of early 2020. And then there's Johnny. Johnny is the head of science at Boulder Academy, and I'm Tash, and I am the assistant head of science at Boulder Academy as well. And we are so grateful for everyone joining today and really excited to see what this morning has to offer. So Science in Practice is a network that aims to bring inspiration to all science teachers through support, collaboration, and positivity. The vision for Science in Practice is to offer a platform where all science teachers, regardless of stage or experience, can interact with one another, learn from each other, and discuss key ideas in a supportive and meaningful environment. As a Science in Practice committee, we feel that it is essential that our network demonstrates three core values: being collaborative, being inclusive, and evidence-based. And throughout today's conference, we will be drawing upon these values, and looking into the future, we hope to embody these values in all of our future events. So what's our journey so far for those of you that are new to Science in Practice? Well, we formed in February 2020, and we had one in-person event based in East London looking at supporting classroom teachers in developing the topic of electrolysis. However, in March 2020, lockdown hit, the COVID-19 pandemic, and there had to be kind of a shift in how we had our events. So we moved on to the virtual forum and Zoom, and we've held lots of different types of events so far. So we've had conversation series where we all come together in more of a collaborative approach with everyone's cameras on and mics on, and we discuss key ideas in the classroom like retrieval practice, questioning, modelling, and they've been fantastic. We've had some smaller coffee chats with our small repetitive network members, which have been lovely. We've had book club over the summer discussing why making every science lesson count. And today is our fantastic conference, which we're really excited about. We have loved connecting with our network so far this year and building our network up and building as many science teachers into that network as possible. So if you don't already, please follow us on Twitter at Practice Science. And throughout the conference today, please tweet us using SIPCon2020 hashtag, and we will be sure to retweet and get back to you with your fantastic questions and comments. We'd also like to say a big thank you and shout out to Teach First. You can see that Teach First are a big part of Science in Practice, and our network coordinator, Laura, the network connector, has made a big impact on Teach First and impact on Science in Practice as a network, giving us valuable advice and support as we have grown. So thank you, Teach First, for everything that you've done to support Science in Practice. So just before we get started by looking at the lineup, our fantastic lineup today, I'm just going to go through a few housekeeping points with you. So firstly, if you have any technical difficulties, please just either DM us on Twitter or email us, and someone will get back to you as quickly as possible. When you are communicating via Zoom, there are two different functions. There's the Q&A function and there's the chat function. For the Q&A function, this is a specific function just for questions for particular speakers. For our keynote speakers, there will be a Q&A at the end where Johnny or Kieran will be asking some questions from that Q&A box for the keynote speakers. If you have a general question for a panelist, please post it in the Q&A box starting with their name, followed by your question, and they can get back to you by typing a message in there as well, specifically for your question. Using the general chat function is fantastic for general contributions for today, and please make sure that you alter your settings to make sure that you send it to panelists and attendees rather than just to panelists, so that everyone on the call can see your fantastic contributions. All of the resources from today will be shared on our Google Drive, so there's no need to take avid notes. You can collect the slides and the links through the Google Drive later today. Finally, this event is being recorded, so hopefully it can be available to you all later on as well. We feel absolutely privileged to share today with our fantastic key speakers. You are in for an absolute treat. So over to you, Hannah, to talk through the structure of today. Thank you.
Good morning, everyone. So I've got the absolute pleasure of introducing the fantastic lineup that we have today. I'd like to say a massive thank you to everybody here for all of the effort they've gone to produce the stuff to produce to everybody, and for taking the time out to share their practice with teachers, because we know ultimately it's all going to impact on those fantastic students that we teach. I've already got a 2-page notebook spread just from the small conversations I've had listening to people's ideas about talks. So I know by the end of today, we're going to have so many new ideas to implement into our classrooms. So without further ado, today's lineup. In a few minutes' time, we'll be hearing from Amanda Fleck, and Amanda will be discussing the importance of science and the barriers that there are of learning literacy within science. We'll then be having some short talks from Catharine Driver from the National Literacy Trust and Rose Edmondson, who will both be discussing reading within science. And after that, we'll have a 10-minute break. So after that 10-minute break, we'll hear from Eve Richardson, who is the literacy coordinator at Boulder Academy, about how she has introduced the SEEK model throughout the academy for different curriculum areas. We'll then have a second keynote speaker from Carole Kenrick, and Carole will be discussing different strategies that she's used in both Key Stage 2 and Key Stage 3 and Key Stage 4 science lessons, so throughout the whole range of our students. We will then hear from David, Gash and Andy Marwick, who will be discussing the Freya model and etymology, and discussing different ideas that we can use in the classroom that will be very impactful on our students. And lastly, we'll be hearing our third keynote speaker from Mary Myatt, who will be discussing headlines regarding literacy across the curriculum and how we can implement those in our subject. And then we'll end the day just with another thank you and a little bit of reflection on what we've heard today. So as Tash said, everything will be available. We will pop the link to the Google Drive in the chat at the beginning of every talk, so you can access that easily. And we hope you enjoy yourselves. So please just let us know what you think and keep the conversation going online as well for us. I will hand over to Johnny now so that we can get started.
Hi everyone, thank you Hannah and Tash, and just to echo how great it is to see everyone here. We are super excited and I hope that you are all as excited as we are. So to start, we have the amazing Amanda Fleck to kick us off, and Amanda is an assistant head at a school in West London and is a real advocate for promoting literacy in science. She has many years of experience in education, varying from being a science teacher to a resource developer to a senior leader. So we're really happy that you can join us here today. Those of you who want to do a bit of homework after the conference, please check out Amanda's Literacy and Science course in Seneca. It's really fab, and I would recommend you do that. A reminder that throughout Amanda's talk, if you have any questions, please use the Q&A function. But I will be quiet now and hand over to you, Amanda.
Thank you, Johnny. I'm just going to share my screen and get started. Hello, everybody. Amanda Fleck here, and I'm particularly interested in the barriers, breaking down barriers to language and literacy in the science classroom. As you can see there's a little image of me reading during Idea to my Year 8 from Bill Bryson, And I absolutely loved this. I love this book, and I loved reading it to them. And you've never seen anything quite like a lot of a full classroom of year 8s with the chin on their hands, listening avidly to Bill Bryson. Right, oh, and my slides are refusing to move forward, but we'll get that sorted. There we go. Right, I was really privileged to be asked to be involved, to be on the advisory panel of the Education Endowment Fund's Improving Literacy in Secondary Schools. It was quite strange to be there, because a lot of the other people there were either English specialists or from humanities subjects, and you know, science isn't technically always known as as a subject that people delve into the literacy and language of, but I think it's absolutely vitally important, and it was really nice to be able to have a voice there. So there are 7 recommendations. I'm going to concentrate on 1, 2, 3 and 4 at the moment, because it's just so vast, I can't get that done in half an hour. So literacy and language, I actually prefer to talk about the terms together, and language always comes first, because language involves the development of skills used to communicate with other people. And there's a great little course on Seneca about language development. It's not the one I wrote, it's another one about sort of how language is developed and how children learn to speak. And I think language is really, really important to speak about, rather than just literacy, because I think literacy sometimes, in my experience in schools, literacy's been very much about getting the students to write, getting the students to read. But before that, we need the students to have the language to be able to do that, and also be able to speak about it before they write it down. And literacy development involves the ability to read and write. So what are the barriers? I'm going to go through these barriers in today's session. The language is vocabulary, then the general academic vocabulary, which we tend to say is the tier 2. And then it's actually students having knowledge, because if you don't know the meanings of the words, you can't carry on. So we're going to dissect those a little bit more in the talk. And literacy, reading academic texts. Are students reading for pleasure, and how we get students to write more formally? Then a little bit on socioeconomic status, and finally, teachers' knowledge and skills. And this is my real area of interest, well, vocabulary and teachers' knowledge and skills, and improving teachers' knowledge and skills. And that's why I'm here today, because that's what I want. If we upskill ourselves, then we can help our students. Anybody who's seen me speak before will know this is one of my favourite quotes. Biology is not plants and animals, it's a language about plants and animals. Astronomy is not planets and stars, it's a way of talking about planets and stars. We would not have science without language. The academic language of science is a challenge, but it isn't, you can't understand science unless you understand the language of science. So why does language matter in science education? There is a 30 million word gap between children of the wealthiest and poorest families. If you do not have the words, if you do not have the vocabulary, you cannot access academia in any way, shape or form. And the word gap is evident from 18 months. And this is from a new report from the OUP. It's a fascinating report. There's links through everything on here, and it's about the transition between primary and secondary. 92% of teachers think school closures have contributed to a widening of the word gap. And I know at my school, what we're doing at the moment is we're putting a project together to actually look at that. How are our year 7s? What did our year, when they were in year 6, what did they miss? So I'm going to look through some of these recommendations. The first one is prioritising disciplinary literacy. And I've said this before, I think this report was a game changer. And it was a game changer for all subjects, because before, literacy was the domain of English teachers. Not that that's an issue, but I think we all need to be, as educators, involved in literacy, because as I've said before, our subject is delivered through the medium of language and literacy. So disciplinary literacy. And then the second one is vocabulary instruction. If we do not have the words, we cannot communicate. And also students, so I'm going to talk a little bit more about that in detail. So what are the issues thinking about vocabulary? The photosynthesis topic we teach this in year 10, and the photosynthesis topic has 68 keywords. And those are all the words they need to learn, not just the vocabulary, but some of them are the processes like transpiration, photosynthesis itself, respiration. All of those things, they might need to know what some things are. They need to know what a guard cell is. But how it actually works is all embedded in this language. You've got on here things like inverse proportion, directly proportional, correlation, concentration. If those, and that's 68 words, most of the new words that they need to learn before they even have an understanding of the concepts. And that is huge. We are fluent as teachers in this language. Our students aren't, and it can be very overwhelming. So tiers of vocabulary, most of us have heard about tiers of vocabulary. General academic language would be classed as tier 2, and this is often an issue for students in the carrier language that we use. Tier 1's not so bad. That's generally what children come into school with. And tier 3, actually, I think science teachers are pretty good at this, actually decoding some of those more complex language, but it's some of the tier 2 language. And just as an example here, I use a lot of images in my PowerPoints, in the lessons that I do, and I was Googling for, obviously, the word tissue. Now, tissue is a tier 1 language. It's tier 1 word. It's vocabulary that students come into school or primary school knowing what it means. But tissue is a tier 3 word for secondary education. So I think there's 2 images on here, 2 or 3 images on here, 4 actually now, that actually relate to the tissue that I was looking for. And those are the difficulties. If we don't say to students, if we don't highlight it, if we don't signpost it, and we just go, this is a tissue, there we go, let's move on. Tissue is a group of cells that work together in a specialist way. There we go on, let's move. Our students are going to struggle. So why is this important? So if we think about our subject is huge. This is something from David Didow's Learning Spy. Subject domain is huge, and the vocabulary in that subject domain is huge, but the specification is quite small. But we still need all of the language from that subject domain in order to make sense of the specification. Even though the examination may not include all of the specifications, certainly doesn't include all our subject domain. If we don't understand the wider context of language, then our students will find this really, really challenging. Core versus hinterland knowledge. This was from a fascinating speech by Christine Council. So we have our core knowledge. These are our basic facts that we learn, but it's all based in context. And that context is pinned to the language that we use. I love an anecdote. I don't know if everybody else does, but my students love it when I go off on a bit of a tangent with an anecdote, but it makes our subject richer. And it's based in the language that we use. To understand the subject in depth, we need this hinterland. And this hinterland is rich in language. And very often it's the tier 2 language that's embedded in it. So we need to make sure that, again, we are signposting why this language is important. So recommendation 3, develop students' ability to read complex text. Training focused on teaching reading is likely to help secondary teachers teach their subject more effectively. Now, this is a huge, huge thing for me, because if we don't know as teachers, in my 22 years of teaching, I have had no training whatsoever on how children learn to read. Now, primary colleagues amongst you may know. And when I do a speech, or do a conference live and there's people there, this is one of my questions. How do children learn to read? Does anybody know? Please put your hand up. And the only people who generally put the hand up are either people who've trained in primary or parents of young children. Now, my children are much older, and we didn't do phonics. My children did whole word reading. They didn't do phonics. So I knew very little about phonics, and the only thing I know about phonics is what I've actually researched myself. So phonics, these are the smaller phonemes. These are the smallest units of sound. They are put together to make words. And in the English language, there are 44 of them. You can see the little infographic there, which just shows code. Graphemes are the way of writing them down. They can be made up of 1 letter, 2 letters, or 3 letters. Now, phonemes, students will gain from the language that they speak. But graphemes are different. Students, they don't just come naturally. Phonemes come the way students speak, when they're speaking to parents, speaking in families, and speaking to friends. But graphemes don't. Children have to be taught how to write things down. And then decode is to read a word, and students become quite fluent on this quite early on. And encode is how to spell a word. Now, students aren't taught how to read much past the age of sort of 7 or 8 at school. I think primary teachers do an amazing job. They take the spoken language and make it into the written word. And for me, that's absolutely fascinating. And by the end of year 6, I've got an example of some work from a year 6 later. And students are, it's just amazing what they can do. So decode and encode, and we'll talk about that later. So how do they learn to read fluently? They use phonics to decode, then eventually they'll get to visual recall so they can see the whole word on sight. And then fluency is recognition of the word automatically. Now, in science, we can struggle with fluency. And the reason that students can struggle with fluency is because we have this complex language, many polysyllabic words. And there is a reluctance from students to pronounce them properly, even up to 6th form. If you've there's an example that I have from my year 13s who were really competent, and it was actually the most accomplished girl in that group who was telling me about an enzyme that she'd researched and would not use the name of the enzyme because she didn't know how to pronounce it. So we decoded it. So we had a 10 or 15 minute talk to the rest of the class on how we decode language and actually breaking it down. And so now we have a practice of that before we actually start speaking. And that's still complex for all of us. We come across words that we may not have known. So if you can decode, you can read this. This is the Jabberwocky. And I use this as an example. Students that can read this really easily. It's a nonsense poem by Lewis Carroll. Just take I'm going to give you a minute or so just to read through that, please. I've probably done that teacher thing where I don't give you long enough and don't give you a minute. But what I want you to do now is I want you to have a look at the questions. And imagine that you've given this to a student. This is what science looks like to some students. We'll say, here you go, here's a section, here's a passage, here's something to read. What I want you to do is I want you to read this science. There are complicated words that perhaps don't make sense, words that the students have never seen before. And then you ask these questions. What were the Sliderstovs doing in the web? How would you describe the state of the borogoves? Describe how the Jabberwock went through the Tulgey Wood. What can you say about the mome rats? You will all be able to answer those questions. So will many of your students. Those of your students with good literacy, even though they have no understanding of what this means, will be able to answer your questions. And this raises a question about comprehension tasks that we can give to students. What appears to be correct answers, what appears to be the students can read this and they have a good understanding, we have to be really careful of, because you will, whether you mark in, I don't know, red, pink, purple, green, or you don't mark at all, you will see that the students who are good readers, who have good literacy, can answer these questions, but still maybe not comprehend. I mean, I've done this several times. I'm no English specialist at all, and I don't know what it means. And I know this is something that's studied in primary schools. But I do want people to think about the fact that we have to be careful about how we are getting students to answer questions on things that they've read. Even if they can decode it, there's still maybe very little understanding. So this is why knowledge is important. To comprehend complex texts, and that's exactly what the academic texts in science are. Very high reading age, very complex language. To lower the reading age, we shorten and attenuate the sentences, where sometimes we can lose meaning. It is nobody's fault it is difficult that science texts and science exam papers have a high reading age. It is all down to the vocabulary. So again, students need to actively engage with what they're reading and use their existing subject knowledge. if you don't have a knowledge of the language and subject knowledge, it's very difficult to read. So this is a GCSE biology text, year 10. And it's all about the hormones in the menstrual cycle. I used to find this really, really, really hard to teach, because we'd have a read through it, we'd do the diagram, we'd see the diagram and the graphs, which don't really make it any easier in my opinion. And then we'd expect children to learn it, and all the interactions. There's an awful lot going on there. There's the complex language, follicle stimulating hormone, estrogen, progesterone, corpus luteum. And then there is a general understanding of the processes. So that's a typical GCSE biology text. You cannot get students, maybe some exceptional students who have a really clear understanding, but you cannot get students to read that and gain understanding from it. You have to teach it. You have to decode the language first of all, and then teach the processes. Even more so, I've just been teaching year 13 respiration, and this is from their textbook. Now, I got my students to read this before we taught it, and you know, even my most high attaining students were struggling with the language of this. It is really, really complex. So you need to break down the language. You need to look at it. What does phosphorylation mean? We've already talked about phosphorylation. Chemiosmosis, they're familiar with osmosis, but not chemiosmosis. Reduction, oxidation, some of them have forgotten that from GCSE. So we went through, decoded the language, did some processing, worked on this. And then once we taught it all, we went back and we did it again. We read it, and then they could read for meaning, but they couldn't read for meaning before we'd done some work on this, before we decoded that language. And these are the barriers that we are dealing with. We can't assume just because students can read and decode that they can gain understanding from that. Now, I haven't got time to go through this video, but I really do highly recommend it. It was an absolute revelation when I watched this. It talks through how teaching content is teaching reading. You need the content to be able to read. And there's a little summary here, but please do watch this at some point. Once students learn to decode, they can decode anything. But if you have a student with a reading age of 6 or 7 or 8 in a class, they're still going to struggle with decoding. It's not that they can't decode, it's they can't understand what they're reading. Comprehension requires prior knowledge. And even if it's just prior knowledge of that language, we need to teach that knowledge. And you can't boost comprehension through reading strategies. You aren't going to improve somebody's science and comprehension of science by just getting them to be able to read. We need to be able to, we can't just give the words and we can't just get students reading. It's got to go hand in hand with teaching of the knowledge. So we've been talking an awful lot about reading for pleasure. I am an avid reader, and I'll be honest, it's been a pretty busy time. And I've really struggled to be able to read, but these are the sort of things that I'll read for pleasure. Bill Bryson's Mother Tongue. I've also got I love a bit of Bill Bryson, the new Bill Bryson's The Body. So I read, even with reading sort of more non-fiction, I will struggle, but I love reading fiction. And what I do is I will use my fiction to improve my vocabulary and my tier 2 vocabulary. I like to think as a science teacher, I've got a fairly wide-ranging vocabulary. But sometimes I struggle, and our students struggle. And this is the language. Reading for pleasure will develop their tier 2 vocabulary and the carrier language. I use these in school. They're actually for 11 plus. And I just choose 1 or 2 words a week of language that students may not have heard of. And the first one at the frontier is Herculean, a Herculean effort. You know, I mean, if I'm talking about a science teacher and I'm saying they, or a famous researcher, a famous scientist, and saying there was a Herculean effort to, you know, a Herculean effort around the world to develop a vaccine. Students may not understand what that means, and it's just going through that language and giving students every opportunity for reading for pleasure. This is from the OUP report. The majority of teachers surveyed are concerned that pupils have read less widely for pleasure during lockdown, and that reading for pleasure was a significant role in helping reduce the word gap. And I absolutely agree with that, especially now that students have access to devices. The students in lockdown that were asked to, that were working on lessons, on the computers, on their iPads, on their phones. It's easier to scroll through your phone and get bite-sized bits of knowledge than it is to perhaps pick up a book. And I love reading, and I'll be honest, I haven't read a single novel since I used to read a novel a week, a novel every 2 weeks. I haven't read a single novel. And that has impacted on, not only on my well-being, but on just sort of the language that I use, the fluency of the language that I use. So my treat to myself is to make sure that I have at least an hour of every day, you know, even if I go to bed earlier an hour, is to make sure that I'm still reading for pleasure, whether that is fiction or non-fiction. So breaking down complex, this is recommendation 4, breaking down complex writing tasks. Writing is a challenge for students in every single subject. And I think in science particularly, it's students can write. We've all seen this, you know, when we were practicing our 6 markers at GCSE, is the fact that students can write an awful lot. Whether it contains the correct science or not can be debatable. Even my A-level students will still regularly go over their allocated space for an answer. And it takes training to do that. So students need to be explicitly given instruction on how to write. And I think this is something we struggle with in science because we're so busy trying to get through the content. So what do we get students to write in science? This is an example of something from year 6. I just Googled year 6 writing, found this on Pinterest, and I'm always absolutely delighted to see what year 6 write. I work with them. One of my roles as an assistant head teacher is to work with the primary school. And when I go and work with them, I'm always blown away by what year 4s, 5s and 6s can actually write. Often in science, we do this. We are so busy trying to get through. We need to get the vocabulary, and we're not always doing this. And I'm not against gap fills or anything like that. But I was looking at my year 7 books when I marked them, and I've given them some great worksheets to actually embed their knowledge, but very little time for free writing, very little time to answer the questions, saying, write down, compare atoms, elements, compounds, and mixtures. I'll give them a nice worksheet with directed questions. But I found when I was marking the books that I wasn't giving them enough opportunities to write, and I wasn't scaffolding. So I've been scaffolding more, usually using my visualizer. So I would do something like this. This is cell division, maybe with my year 9s in GCSE. I'd talk about cell division. I'd give them something like this, but I must make sure I back that up with the ability for them to do some free writing. This is something from the 2013 Maintaining Curiosity. And what stands out here is we can assess understanding, but we need to get students to write and talk at length. Oracy comes before literacy. Give them opportunities to talk to each other and get them to sit and write quietly for 20 minutes about what they know. Give a good rubric for them to be able to write more about that. So we need to get them thinking. Because as Professor Rob Core says, learning happens when people have to think hard. And I tell my students this, you know, when you have one of those lessons where there's lots of processes going on, lots of language, lots of challenging things, and students go, oh, miss, I'm exhausted. I said, that's because you're thinking hard and you are learning. That means you're learning. So socioeconomic status and the word gap, and I think this is coming up in somebody's presentation later. This is again a report from the EEF written in 2017. Children from lower income families and those with English as an additional language have a larger word gap. And this is an issue. I work in a school in West London. We have lots of students who are EAL and from low income families, and there is that word gap. And we, not always, you know, but generally that's what research shows. However, the strongest and most consistent predictor of students' attainment in science is how literate they are, how they can read and write, not necessarily what their potential is or any of those things. It's how well they can read. And we need to redress that balance for our students who are from those lower income families and or do have English as an additional language or any other additional needs, we need to make sure that we are helping them access that language, because if we don't, I've had students who have a fantastic grasp of science. And I can remember once a boy, Sean, he must be nearly 30 now, who was in the lowest set in year 7, 8 and 9. He was fascinated by science. He'd do science projects with his granddad. He did electric circuits. He had a wonderful grasp of what we were doing. He could not write it down. And he became more and more disenfranchised the further along school he went. But he was actually a fantastic scientist. But because of his literacy, he was stymied when it came to exams. So another fascinating thing, and this is one of my particular areas of interest, is, so this is Dr. Jess Ricketts, and she talked about the fact that secondary teachers support students with vocabulary. They don't have the knowledge and resources to help those students. And that's why this conference is absolutely fantastic, because we are addressing literacy in science. We have a lot of practices in schools that address literacy whole school, and this is why I love the EEF report, because it puts the onus on the literacy across all disciplines. So this is what we did. We started with the why, and this is what we did in my department, and looking at staff training. You need staff training for literacy and language. So the rest of my slides are just about where you can find out about language and literacy. I'm not going to go through each one of these, but everything I've mentioned is in here. And thank you very much. That's the end of my talk. Any questions?
Thanks so much for that, Amanda. And I have got copious notes myself, trying to keep up with all of the fantastic points you're making, particularly as I'm about to go into photosynthesis as well. So that slide that you showed has just given me an alert of how many words we're going to be teaching. So yeah, thank you. That was absolutely brilliant. We have a question. Well, we have quite a few questions, and we've got one from Tyler Hunter, who has said, as the command words fall into tier 2 language and can have slightly different meanings across different subject areas, how would you recommend addressing this with students in science specifically?
I think, first of all, you've got to identify which ones cross over. So you have to have your departments speaking to each other. And I think this is addressed by CPD. Gumley House School, which is near where Johnny and I teach, they asked me to go in and deliver a session on the Education Endowment Report. And one of the first things that they did was they had a whole CPD on heads of departments working together to look at the command words that are addressed across each one, so that they were aware of the language that was used in other subjects. So I genuinely think that the first thing you have to do is talk to the other departments, see where those command words come up, and then actually address them in the subjects and signpost to the students. This is the most important thing. This may mean something slightly different in English, in geography, or actually a lot of them are exactly the same in geography. And that's what was a revelation to one geography teacher. It was a head teacher who had just delivered some language and literacy CPD to, and she was part of it. She goes, "Oh, I'm a geography teacher. It means the same in geography." And then an English teacher goes, well, actually, we don't use explain in the same way. So I think it's about the science, it's about that CPD and speaking to the heads of departments and saying, can we look at what's shared, and actually, how can we make it specific for the subject? And right from year 7, talking about what these words mean. I'm not saying give GCSE questions, just talk about how they are used.
Thanks, Amanda. That's really, really helpful. And we've also got a few questions, 2 or 3, around comprehension strategies. First of all, where's a good place to sort of get good comprehension texts, and then strategies for sort of going through them?
Right, I'll see if I can put a link on Twitter. I found quite a lot of these. There's, I'll tell you that WJEC, they do PISA questions, and their PISA questions tend to be longer answers, a bit more like the old AQA ones used to be, and they have text based on that. So WJEC is good, and I found there's I think it's an American website where there's lots of comprehension activities. But I think anything, but it's anything where it's long text. Even if you're doing your comprehension questions yourself, I think you need to say, you can have a couple of the what type of questions, but I think you need to sort of ask a description of processes and then explanations of answers. So if you do a what is this, what is that, what is the other, and then describe this process and explain that, I think it's fine. I think you can use any text at all, but don't dismiss your textbooks either. I mean, we seem to be, people have become a bit anti-textbooks, but don't dismiss them. Look at the question. Actually, no, that's a brilliant question. There's a piece of text there, and that's a fantastic question. I'm going to use that, but I will put some out there. They're not necessarily that easy to find, and they tend to be a little bit old-fashioned. But and also edXL had some really fantastic resources for the 360, and they had quite a few on there. But I'll tweet some out. I'll find some and tweet some out.
Thanks so much, Amanda. I wish we had time to ask you some more questions because it's been popping off, but I'm sure you'll see some of them on Twitter. So moving on to our next speaker, it's Catharine Driver from the National Literacy Trust. And we're absolutely thrilled to have her joining us today for a short talk on reading for learning in science. And Catharine is a secondary school advisor for the National Literacy Trust and is also the regional lead for the Trust's Literacy for Learning programme in the Northeast. So we really do feel privileged to have her with us today. And she has experience across EAL and science as well. And a reminder, if you have any questions for Catharine throughout her talk, please use the question and answer function. Over to you, Catharine.
Okay, hello everyone. Really pleased to be here. Really excited to find such a big community of people who are interested in literacy and science, because this is something that has been really dear to my heart for, I think it's about 30 years now. I am not a science teacher. I originally started out as a history teacher, but I would now call myself a linguist. It's fair to say that my subject specialism really is literacy across the curriculum. It now has a new name. It's what you're all calling disciplinary literacy. And I have been doing this, as I say, for practically my whole career, originally as an EAL teacher and now as a sort of language and literacy consultant much more widely. So I'm going to share my screen. I've only got 10 minutes. I'm going to try and pick up on a few things from Amanda's talk as well, which was really, really helpful and really interesting. It's kind of, there's a lot of overlap, and there's a few things she said that I'm going to say a little bit more about, and there's a few things she said I wish I had more time to talk about. I'm not going to be able to read the chat while I'm talking, as those of you who've probably used Zoom a lot know how incredibly distracting it all is, but hopefully I can pick up on some of the questions afterwards through the chat session. So a little bit about reading for learning in science, a little bit about the work of the National Literacy Trust as well, because this is an area we're really looking to expand, which is one of the reasons why I said I'm really excited to have sort of found you all online. I do have a Twitter account. It's not an official National Literacy Trust Twitter account. I'm at Catharine EAL, representing the fact that I was for many years an EAL teacher. There is also a National Literacy Trust Twitter handle there, and these slides are available in the Google Drive. So the National Literacy Trust are actually a charity that work largely with schools, but also with communities to transform literacy in those poor communities. So Amanda was picking up on the issues of those children from lower socioeconomic backgrounds who may have very different sort of cultural experiences and very different reading experiences. So this is exactly those sorts of communities that the National Literacy Trust works with on a daily basis. And my work is very specifically with secondary schools as part of this large secondary school improvement programme that's now been running for nearly a year and a half, and is likely to continue well into next year. And I was really pleased to see, I think we've got someone here from Berwick Academy. And as I said, as Johnny said at the beginning, my area is the Northeast. And I have actually had some training sessions with schools as far north as Berwick. So good to see you here, or virtually see you here. So Amanda mentioned this research came out about 3 years ago, a collaboration between the Education Endowment Foundation and the Royal Society, and picking up very strongly on the fact that disadvantaged pupils attain lower and make poorer progress in science at every key stage, but most notably between the ages of 11 and 16. This is not a surprise because, of course, the same is true about disadvantaged pupils in English and in maths. It is a concern nationally and has been for a long time. But what was particularly interesting to us at the Literacy Trust was the fact that it was clear from the data that the strongest factor affecting pupil science scores is how well they understand written texts, and that this really sort of underpins the need for all science teachers to be thinking about the language and the literacy in the subject, which, as Amanda has very clearly outlined, can be quite a considerable barrier to their science learning. And I should say I've got a very real example of this in my own life at the moment. I'm tutoring a young political refugee. He's Turkish. He came to the UK just before the lockdown. He came from a school in southern Turkey that was a STEM specialist school, so a really top high school in Turkey. He's clearly excellent student, particularly in maths and physics. His mother is actually a physics teacher. And I have been tutoring him right the way through lockdown. Obviously, I can't help him with the maths and the physics. I'm doing my best to help him with the English. But he just did a set of mock exams. He got a grade 9 in maths and a grade 8 in physics. So that is where he is with his science, but his English is always holding him back. He can learn the science words, but he needs more than the words. He needs the sentences, he needs the paragraphs, he needs that higher complex understanding and comprehension. He aspires to go to sixth form in a top university, and I'm going to make damn sure he gets there. So the first thing I want to say about science reading is that it is highly multimodal. And this is the really, really critical factor, that when we're talking about reading and comprehension in science, we are not just talking about words. We've got to think much bigger than words. And here's an example of a recently produced textbook suitable for the AQA syllabus, but aimed at the Key Stage 3 preparation stage for that AQA syllabus. And you just look, I've pulled out one page from one textbook, how busy that page is. This multimodal nature is very much more true of science, technology, maths, or geography, all those subjects. So when English teachers are teaching reading, they are not teaching this sort of reading. In English, you read a whole page of words. In science, you read headings, captions, photographs, diagrams, tables, data, numbers. Just getting the science out of this page is quite a challenging task. For me, as a non-scientist, my eye is immediately drawn to the colourful bits and the picture. And I think you need to, when you're teaching science through using a written text, be really, really conscious about how it actually looks on the page, and help the students to understand how the page itself is organised. And I would immediately, at the beginning of, say, year 7, when I'm introducing some work from a textbook, spend a bit of time helping them negotiate the actual book itself. Do they know where the contents is? Do they know how to use the index? Have they found the glossary? Do they know that when something is in a purple box, that's the question? Do they know when the vocabulary is in a yellow box? Those are the key words. Do they understand how the caption relates to something that is referenced in the text? Can they find their way about the page? So that's my number one advice about reading in science. Think about the texts you're using and how accessible they are as a whole page. So quickly going through some of the barriers, I think Amanda's already picked up on quite a lot of these things. First of all, and I've sort of mentioned this already, students in Key Stage 3 are very familiar with narrative and recount texts. That's what they're exposed to in primary school. In Upper Key Stage 2, they're very unlikely to be spending time reading textbooks in any subject. But so secondary science textbooks like the one I just showed you are very unusual, new to them. So your Key Stage 3 students will need training with how to negotiate the textbooks, because it's a different type of reading. Yes, they do need a much wider background knowledge in order to read, because they're having to draw on these things that Amanda talked about in her talk, the hinterland knowledge in order to understand the science. So they need some general science knowledge, often some general knowledge outside of the science, as well as moving into this very specific scientific knowledge. They also need a much wider academic vocabulary, which they're not going to find from reading fiction. So it's, again, different sorts of vocabulary in science, very different, particularly the vocabulary based on Latin and Greek that I know other people are going to be talking about later. Then a much wider range of reading strategies needed for science. And because of all this, a lot of science teachers think, oh, I don't really know how to teach reading, or this textbook is really, really difficult. I'm not going to use it. And so the science teachers just don't build up that resilience. They don't really know how to manage it. And the children need help to do it. It's no good saying, oh, well, I'll just talk, or I'll just explain, or I'll make my own worksheet. Actually, you need to help them negotiate it. And I've got one strategy to help you do it. And this is based very much on my thinking from reading the work of this linguist, Michael Halliday, where he says the difficulty lies more with the grammar than the vocabulary. It's not the technical terminology that is a problem for a lot of students, but it's these relationships between the words. And I'm going to illustrate it here. You've got this in the worksheet. It's about using pronoun referencing. And I'm really sorry, I haven't got the time to talk through this. The key thing is to focus on these little words in the text, like it and this, which refer back to previously mentioned nouns. And if you don't highlight the way these words work, students will not actually be able to understand what they're reading in the complex texts. We've got training on this for the National Literacy Trust. You've got the link on that slide. And I've also made a link to some further reading.
Thanks very much for that, Catherine. Really, really interesting, your point around training students for textbooks. And I think that's something that we really don't do enough in secondary schools. So that's something that we've really, really picked up on. So thank you so much for sharing. Apologies, I know it's a swift changeover today and we've got lots of people to go through, but thank you very much for that. We don't have any time for questions at the moment, so if you do have any questions for Catherine, please pop them in the chat, in the Q&A, and she can respond to them there. We're moving on to Rose Edmondson now, who has had 17 years of teaching experience across both secondary and primary. That builds on Catherine's talk there. And she's an advocate of Wonderful Word Wednesdays. I'm not sure if you've seen on Twitter. She's well known for two things, her literacy prowess or her tortoise. So hopefully your tortoise doesn't upstage you today, Rose, and I'll hand over to you now.
Thanks, Jenny. Yeah, he's being quiet at the moment. So, you know, he's now just staring at me, though, so I'm not going to look over there. So I've started my timer, so I know how long I've got. But it is quite tricky, isn't it, to fit everything in? So I'm going to start to hopefully share my screen now. So I'm hoping that when this plays, please let me know if you can't see that. But what an absolute privilege it is to be here today. I massively appreciate what Amanda has said and what Catherine's just said, and I'm probably going to be continuing with the theme because, as you can see, the title for my quick talk today is it's basically strategies around reading. It's going to be more about what I've tried and what I'm currently trying out in the classroom, but obviously having seen what's been used in primary, I feel like now I'm definitely I've learned so much from that I'm bringing that into my secondary science classroom. Again, I don't know that my Twitter handle is the most appropriate given the current pandemic, but there is a reason why I have that Twitter handle, which I won't go into right now, but I am SnotLady5 on Twitter. And also some more of these strategies that I mentioned today, I've done a couple of blogs sort of summarizing them in a bit more detail, but a lot of the strategies that I've tried have come from this amazing website. It's American. It's called the SERP Institute, and they've got so much, and it's not just reading strategies. Actually, there's vocab lists on there if you want to incorporate more debates, so around oracy, using that cross-curricular. Actually, it's a fantastic website to become familiar with, and also the visuals are brilliant. So sort of coming back to what Catherine and Amanda have already mentioned, just looking at specifically science and reading in science, it can sometimes just look like that to some children. So I'm going to try and give and talk about some of the strategies that I try and use. So just before I get there, so some of this has already been mentioned, but research wise, I can't get over this. I know it was more than a decade ago, almost 2 decades ago now, but actually at Key Stage 3, there has been research that suggests that actually at less than 10% of the time in a science lesson at Key Stage 3, children are reading, which is bonkers considering, you know, how we expect them to unpick science questions in exams, and how we want them to answer questions. So that just has blown my mind. So if it's like that in secondary, it's probably going to be even less likely that they're going to be using reading in their science sessions in the primary classroom as well. As has already been mentioned, literacy and attainment in science are very, very strongly linked. So, you know, if you don't have the literacy, you're not going to attain as well as what you could. And then probably my biggest issue sometimes is that we sort of let children, particularly at primary, believe, and quite rightly, that science is a hands-on subject. You know, it's a practical subject, and by practical I mean, like, you know, all aspects of not just, you know, actually using the equipment, but, you know, in having discussions and things. But really, real scientists, a lot of the time when you speak to engineers or you speak to researchers in the lab, most of their time is spent reading around their subject, more than 50% of their time. So actually, real scientists are readers. And I think that's a really important point to get across. So some of this has already been mentioned, so I'll just mention this really quickly now. This is why science can be really, really tricky. And to be honest, way before I taught in primary, I think I took this for granted. You know, there's lots of words that mean more than one thing. There's lots of, so nominalization is about processes. There is an awful lot of confusion, I think, between nouns, so what things are, and also this idea of processes, and processes being things that are you know, something that happens to something. Like Catherine was just saying about logical connectives, sometimes, because, you know, in science texts it's short and condensed, it is very difficult for children to make the connections. The lexical density as well, we've mentioned about how multimodal it is, and I'll come back to that in a second. Also, use of passive voice as well, when you're looking at the way that write-ups are done in practical science as well. And sometimes the visuals are just, even though they're there, having children make sense of them sometimes, particularly around if you're looking at the space topic at the minute like I am, some of the visuals aren't particularly helpful, and it's giving children the time to explore those and to discuss those and to look sometimes at, you know, at different ways of looking at those diagrams in model form as well. So what can we do to help? So I refer back to the SERP Institute. I've put a little Word document in my little folder as well in the Google Drive. So there's the link there as well if you obviously can't link into it directly from here. So if you go into the Google Drive, it's in there as well. And I'm just going to mention now, one of the things that I do, so some of these strategies are, even though it says on the SERP Institute, it's before, during and after reading. A lot of these you can use throughout, but this one I definitely do more now than I've ever done before. So it's called a picture walk. So if you're using a textbook, or you're using some text that uses pictures as well, or tables like what Catherine was saying, Make sure you plan into your lessons time to actually take them through those diagrams, take them through looking at the table. So bring it about as separate, because quite often it enhances the text, but when it's next to the text, it can be a bit overwhelming. So I now on my slides, I show them these pictures first, and we talk through them, we explore them first. So this is just an example of one that I used last week. I was teaching the students remotely, so it made it a little bit easier because they didn't have this textbook in front of them. So I broke this textbook page down, but had I given that to them, they probably would have been like, whoa. Even if they weren't saying it, I will probably very quickly realize there's an awful lot going on there. So, taking those tables, talking through those tables, exploring them, looking at the pictures and the scale, so I'm not saying don't use textbooks. I actually think we probably should, but it's how you use them that is important. Somebody I think put in the link before about the link to the IOP science stories. I use them a lot. They are brilliant for comprehensions. I take sections and I create comprehension activities myself. I structure them around, I don't know if you've heard, if you're primary, you will have heard about Vipers. If you haven't, I haven't got time to go into it now, but basically when I'm coming up with questions for the children, I tend to give them a true or false or multi-choice question first, so that everyone can try and access that. And children are very good at retrieving information from text. I find they've done that a lot at primary. So I do the what questions first, then I kind of move on to the how, and then looking at the why, sort of as you go through the comprehension. But yeah, those questions and that build up to questions, I think is similar to what you'd have in a textbook anyway, but I tend not to use the questions in a textbook, particularly if I'm using texts of my own that I've taken from elsewhere. Other things you can do during the text reading during or just prior to using a text, I suppose. I'll come back to Cornell notes. I know I've only got a minute and a half left, but one of the things here, these anticipation guides, the one on the right there, I found they're working really well. If you can pick 4 or 5 statements that you either know not to be true, so there's going to be a misconception about these, or that the answer is or the statement is true, get them to think about what they know, what they understand first, then get them to use the text. It really forces them to slow down their reading and think about what the text is saying, and embeds their understanding as well. And again, they're very good at finding evidence from text, usually because of comprehension tasks that they've been asked to do at primary. So I find that these are really helping to slow down how quickly they read through a text. Here's an example of one that I've used. I just took some text from, and I'll show you this in a minute, from BBC Bite Size, but I created 5 statements, got them to talk about it first, what they think is true, what they think is false, look at the text, what is that backing up what they think. So it's really good for misconceptions. And that was the text that I used, just taken from the internet. I think I've got 20 seconds left. Here's one that I used just last week about Pasteur. I used this with my year 9s. Again, I took this is from New Scientist. So my year 9s are a little bit, they're used to the comprehensions now. I've almost taught them for a term now, so they're a little bit used to this. But the way I got them to, or the way I get them to look at that text is, oh, there's my timer. I shall stop that. So I'll just finish now. But I tend to move the text over to the right. So they've got a margin down the side. So they can, any words that they can't work out the meaning of, or they've got a question about a text, they can put it there. And then I get them to sum up the passages just with a sentence or two. And then very, very quickly, here's some hints and tips for using longer texts as well. It's called PR2, but it's just getting the children to preview texts and then how to read a bit more actively and then review those. So that's quite good for sort of Key Stage 4 or moving into Key Stage 4 up to Key Stage 5. And again, you can read that back at your own leisure. So thank you very much for listening. There's my contact details and my link to my my blog. Again, if you want to answer and ask any questions, I'm more than happy to answer those for you. So there you go.
Thank you so much for that, Rose. So many interesting and really applicable ideas there. My particular favourite is the picture walk. Absolutely love that. Definitely going to be implementing that soon. So we're going to have a quick break now. So please feel free to go and get yourself a cup of tea, have a little toilet break. If you're all sorted and you're ready for round 2, then we will just share a little science joke with you now, and you can sit there and wait when we reconvene at 11:45. So thank you very much, and we will be back soon. Okay, welcome back everyone. It's lovely to see you all. I hope you all got a chance to have a little break and rest. So moving on to our next speaker, we have Eve Richardson, who is a whole school literacy coordinator at Boulder Academy and also a Teach First participant 2014. I know she's a part of some other Teach First networks as well. And she's going to talk a bit about whole school literacy and how to effectively embed that in your school. So over to you, Eve.
Thank you, Johnny. So yeah, my role is specifically literacy across the curriculum. So what that entails is that I work with all the departments across the school, and actually my job title is lead practitioner for literacy across the curriculum. So we really wanted to, when we started the school, we really wanted to make sure we had a huge focus on literacy. And so today I'm going to be talking to you about the way that I've introduced vocabulary development in the school. And the title for this is Words for Life. And as Amanda talked about and everyone else has, this idea that the words that we teach students at school, particularly those tier 2 words, those are the words that they need for life and beyond school as well. So yeah, I'm a lead practitioner at Boulder Academy, but I'm also part of the English in Practice network. So I am first and foremost an English teacher. So we also started our own network in lockdown. So if you know any keen English teachers, please let them know. The Twitter's just at the bottom of the screen. And I'm also one of the co-founders of Be Her Lead. And what we do is we train female teachers to run workshops for girls in their schools to raise aspirations and to build their resilience. So we work a lot with people in STEM, we do talks, we do conferences. And if you're kind of a keen female science teacher and you want to kind of boost STEM in your school, or you want to kind of run programs for girls in your schools, please do get in touch. I've put all the information there. I also have a blog, we have a Be Her Lead blog, and I've written some blog entries around literacy, around creating a gender inclusive classroom through empowering oracy, and also how you can use literacy to build aspirations. So that's just something else that I thought you might find interesting, but please do tweet me if you want any more information. So what I'm going to be talking to you about today is how I turn the SEEK model into a vocabulary development cycle, how we've been embedding the use of knowledge organisers across the curriculum, and also just a reminder of the explicit teaching of vocabulary and how important that is in all subjects across your schools. So just a couple of questions that you might want to be thinking about today and also during my talk. How are you already closing the vocabulary gap in your science lessons? So what opportunities are you giving for vocabulary teaching? It is really important that it's explicit. How much of your science curriculum planning is vocabulary focused? So do you plan this? Do you plan your vocabulary? And also, how do you explicitly teach that vocabulary? So what strategies are you using? And there's just a couple of quotes there from the Oxford language report, which I think are really, really important for us to look at. And I've shared these with all staff, multiple times. So as Amanda mentioned, the EEF report, which I think is just absolutely fundamental for all literacy coordinators. And really what I started with, I obviously went through the whole report, and I think there's a lot in there for science, which is fantastic. But what we really wanted to focus on was number 2. So the providing targeted vocabulary instruction in every subject. And, actually giving time to teachers to plan this. And it's just so important, and really taking that time. And if there is room in your kind of CPD calendars, in your science department meetings, I just think it's a really, really good place to start. And we've already had kind of really positive results from this. So yeah, like Amanda said, you've got to start with the tiered vocabulary system. And the way we got teachers to plan this is through their knowledge organisers. So I'm going to show you some examples, but it's really important that teachers understand the tiered vocabulary system and are able to actually plan the different types of vocabulary, because tier 2 teaching is actually much more difficult than teachers think. The tier 3 teaching is actually what we're best at. We're really good at our subject specific language. We're not very good at teaching tier 2 vocabulary. It's hard. So what I've tried to do is create a bank of strategies that teachers can use, that students can use to really help conquer this. So because I want to really talk about how I've put my research into practice, in lockdown, I did a lot of reading. It was a fantastic opportunity for me. So my two kind of favourites, I guess, at the moment, or from lockdown as well, are the Closing the Word Gap document from the Oxford Language Report. I've put a link to the science strategies in the Google Drive, which you'll find really, really useful. And also, of course, Alex Quigley's book, Closing the Vocabulary Gap. I also went on his training the other year, and I just think it's a really good, simple way to start. If you've got no vocabulary instruction in your school, no vocabulary development, it's just a really, really good place to start. So what I actually did is I took the SEEK model because I wanted to focus on vocabulary instruction and vocabulary development. So the SEEK model, it's been around for a long time. Alex Quigley, I don't think he actually invented it, but he really talks about it in a really straightforward way, which I think is applicable to all teachers in all subjects. And it's this idea of you selecting the words, explaining them, exploring and consolidating them. And it's really thinking about how you teach these words, but also how the students are going through this process. So I saw this as a vocabulary development process. And I really, really wanted to actually find strategies. So even though I did all this reading, there weren't actually that many vocabulary strategies in what I was reading. So I had to do a lot more digging to find those. And it was once I started to find those strategies that will work for all subjects, that's when I kind of started to collate all this research together. So what I did is I created a very visual vocabulary development roadmap. So we share this with the students, we share this with the teachers. You could use this for curriculum planning, you could use this for lesson planning. And I think it's a really good way to get teachers and students to see that vocabulary development is not just a one-step trick. You've got to think about, first of all, selecting the vocabulary. How are you doing that in your lessons? How are students selecting the vocabulary to write with? How are they selecting vocabulary in a text? How are they finding the meaning of that vocabulary? And then you've got to explore that vocabulary. So giving them etymology strategies, getting them to research the words, kind of finding the fun in that. And we do that through homework, actually. Then they've got to apply the words. So either in writing, in tables, diagrams, where all that wonderful vocabulary they've been learning, how are they then applying it? And then how are they putting those words into context? And then, of course, consolidating. We use this a lot before assessments, giving them homework, giving them different strategies in lessons. So looking at, again, those tier 2 command words and exam questions, mind maps, quizzing, glossaries. So I think this is a really good planning structure for lessons, students, and for teachers. So we have the vocabulary development cycle, but obviously you need to plan the vocabulary in your curriculum. So we do this through knowledge organisers, and there's obviously a lot of research about knowledge organisers, a lot of debate about knowledge organisers, but it's a really good starting point for planning and for really showing students that vocabulary is at the heart of your schools, really. So we give students all knowledge organisers for all subjects every single term. And I wanted to show you the science examples, which were created by Tash and by Johnny, because I think they're absolutely brilliant. And, just the way we've done them, and we've been developing them kind of across the past 2 years, they must have tier 2, tier 3 vocabulary. But also there needs to be images, there needs to be diagrams, they need to be accessible for SEN, EAL students. So we use a website called the Noun Project, which is really good for putting symbols next to words. And I do think that symbols and images are really important in getting students to understand vocabulary. We also use QR codes a lot. So, again, everyone's been talking about, where can we read some extra science texts? And, we put the QR codes on the knowledge organisers so students can go home and very quickly access those texts with really rich vocabulary. So the knowledge organiser should not just be a list of words. It needs to be something that students can explore, can dig into. It should be used in lessons, for homework, for revision. It should be a very kind of multifunctional source that you use. And then, so what I did, so the way that we apply all this, the way that we get the students to apply all this into their learning, is I collated packs of vocabulary strategies that could work for all subjects. And this was really difficult. It was not easy at all to find this. So what I did is I kind of did a lot of research again and really thought about the cycle. And then what the teachers do, they set a variety of different strategies for homework each week. So we've made vocabulary compulsory for homework, and then also teachers are using these in their lessons. And I've attached, oh, there's the Freya model, of course, which I know is going to be talked about later. So just some more examples here. What I've done is I've put an example of one of the vocabulary strategy booklets on the Google Drive, so you can have a look in more detail. And so just to finish, here are some really good science ones that I thought would be really helpful. Vocabulary concept cards. This is more of a consolidate strategy, so you could use these for revision, get students to create them. Concept mapping as well. I took this from the Oxford report, again, which is a really, really good vocabulary strategy for looking at mapping concepts together. And also, we've really been trying to push etymology this year. It does take staff training, I think. I think you need to explain to staff what it is and how to do it well. But yeah, it's a really good way of doing it. So thank you so much. I hope that was useful. And yeah, there's lots. I've put a few things on the Google Drive, but if you have any more questions, please do tweet me or put it in the Q&A. So thank you very much.
Thank you so much for that, Eve. That was fantastic. I am literally obsessed with the Noun project, and you know, I'm really jealous of Boulder Academy for having such an active literacy lead like yourself. So thank you so much for sharing your ideas and resources with us today. Really appreciate it. Thank you. So onwards to our second keynote speaker of the day, Carole Kenrick, who's going to be sharing tools and strategies to develop students' literacy. So Carole has had lots of experience teaching science in both primary and secondary settings, and currently teaching in East London. And she also works for the Institute of Physics and the Ogden Trust. And we've had the pleasure of working with Carole before in a conversation series earlier this year. And every time I watch Carole present, I'm absolutely blown away by her passion and her enthusiasm for science education. So I'm really, really excited about the presentation today. So without further ado, over to you, Carole.
Thank you. And it's so lovely to learn from other people as well. I've had a great morning and I can't wait to see what else is to come. So hello, I'm Carole. If I've not met you before, I have been teaching in primary schools and secondary schools, and now I'm in an all-through school, so I get to teach both, which is wonderful. I also do some work for the Institute of Physics and the Ogden Trust, and the focus today is going to be specifically on developing students' writing and thinking about why they need to write in science and how we can support them to write for different types of reasons. I do want to mention, if my slide will go forward, that I am going to kind of focus on things that maybe you haven't come across. So I'm going to avoid things that will come up in other presentations, such as Freya models, and I'll refer to a few things which I hope you'll know what they mean, and you can follow up if you want to, but 20 minutes, I can't do everything. So just to start, the thing I was asked to do in this session was to provide some clear practical strategies for people to take away. So I've tried to, make it coherent. It's all about writing, but I'm going to be showing lots of photos of my students' work over the past half term and previously, so that you can hopefully see what I do, and hopefully there'll be something for everyone that will be useful. So first of all, just to kind of emphasize that we talk about writing, reading, speaking and listening, and also vocabulary as being what we mean by literacy. And writing is kind of the thing that often needs all the others in place first to be able to do. So I'm going to be talking about the writing stage, but just to emphasize that the vocabulary work has to come first, that time spent reading a range of texts so that they know what to write needs to come first. And oracy, speaking and listening, is a really important part of scaffolding writing, which I'm not going to talk about loads. You'll see it arising as a bit of a theme, but that's something that I'm currently working on developing, and I'll just touch on at the end. So it's worth just taking a step back for a moment and reminding ourselves of why our students need to write. It's such an important thing for them to be able to do in life, not just in science, but in science specifically, we write for lots of different reasons. As a teacher,
I find it useful to think of 3 main reasons why I want students to write in my lessons. They are to develop understanding, which I'm going to call writing for learning, demonstrate or share their understanding with me or with someone else. I'm going to call that writing for communication. That includes answering exam questions for secondary teachers in particular. But also writing can help us remember what we need to learn. So I'm going to kind of share strategies within these headings, because that's how I tend to think of it when I plan. What is the purpose of this writing? That's kind of the first question. Why am I asking them to write? And once I've got the purpose clear in my mind, I can then choose an appropriate strategy. Some of them will overlap. A lot of writing for learning will overlap with writing for remembering and for communication, to be honest. So the kind of key thing I want to emphasize is we need to teach our students how to do these things. Even if we are not English teachers, we are teaching the language of science, and we need to teach them how to write in science. So I'm going to start with looking at writing for learning. So these are tools I use that help students develop their understanding of the ideas through writing. And a lot of the time that will involve pictures, images, graphs. So the 3 strategies I'll share are storyboarding, explaining mistakes, and reflective writing. So first of all, storyboarding, this is something that is great for processes. Last half term, I was teaching some chemistry to year 8. So we had storyboarding pretty much every lesson when we looked at distillation and filtration and all these different techniques and processes. So the first step is to share the image, ideally model what you're doing as a teacher. So I would have, for this storyboard, a balloon. I would have a go at rubbing it on the jumper or on my hair, observe what happens. Once we've had the observation, now let's think about how we explain it. So in terms of the stages, I would then think about what key words do we want to use when we are describing this? What knowledge do we already have about the things in the images? So we might write down some keywords. It's important to bear in mind tier 1 words are important too. That helps us to ban the word it. So often in explanations, children say it does this, it does that. No, we need to be more precise. What do we mean by it? So including those tier 1 and tier 2 words in our keywords is actually quite helpful for making sure that students are precise in their writing. Once we have identified our keywords, this takes a little bit of guidance from me, especially to begin with, we then start to annotate our storyboard as we describe it. So let's start by describing what we can see in the first diagram. We can see there are positive charges, they're bound in the atoms. That's good to remember, they can't easily be moved by friction. Negatively charged electrons can easily be moved. Okay, that's good to know. What about the next one? Oh, we see that after we've rubbed the balloon on the jumper, electrons are transferred. And you're basically step by step, as you explain, adding the annotations. I would usually do this either under the visualizer or on the board, just to make sure that we have got a really clear, broken down, scaffolded explanation. At that point, we'd go back to our keyword list. Is there anything that we've missed? Tick off the ones we've used. Is there anything we've missed? This is part of the redrafting process. That is a really important part of writing. No one writes their perfect answer first time round most of the time. So once we've done that, we think, okay, well, where can we add any missing keywords? When we've done our redrafting a few times, we're happy with our annotated storyboard. Let's number the steps so that we can see in terms of ordering our writing, what are the stages? And once we've done that, we can write our explanation. First few times, I will do some modeling. I might write the first sentence explaining, again, my thinking. There's a lot of metacognition involved in writing. You've got to talk about what you're doing and why you're doing all of the time to show students how to do it themselves, and then get students to write it the next stage semi-independently and finally independently. So you end up with much more structured writing that uses the key terms and is just really clearly organized. So this is particularly useful for younger students, but is a useful tool all the way through the age ranges, I find, as a scaffold. It is important to be able to remove the scaffolding over time. So then starting to emphasize to students, okay, what are our steps? If you're going to do this without me giving you a storyboard, what do you need to do? We need a diagram, we need keywords, annotate the diagram, bullet point descriptions, explanations, and then write our answer. And then we get students to start doing this themselves. So my year 9s, last half term, got to the point by the end of the half term where they were writing their own keywords for an explanation of why a balloon would inflate and burst in a situation, drawing their own storyboards, and annotating them themselves. So this takes practice, it takes careful modeling, it takes scaffolding, but it's important to work towards a stage where students can do that independently. That then enables them to really structure their written answers. And they've basically been taught the process of writing. So that's one approach that I find really powerful, but it also is really important for learning, because this helps them to see how lots of different ideas come together to explain a process. Another tool for which writing is useful is explaining mistakes. So giving students an example of something that someone else has done, which is not quite right. So with year 6, we were looking at light rays. I found they really struggled to draw them in the way that we would like. So I showed them light ray drawing full of mistakes, asked them to identify them. Now you'll notice on the side, what I've been doing with classes who find it tricky to keep their books kind of organized is to just show what I expect to see in their book next to the slide. So I'm gradually trying to train them to structure and organize their notes in the way that I would like to see them. And then students were then able to draw their own diagrams, and the prompt of noticing the mistakes really helped them to draw their own diagrams. So that's a way that kind of that reflective writing almost can be powerful. I've done it as well with GCSE students, so talking about energy, asking students at the start of lesson as part of our retrieval practice to correct some common misconceptions about energy. So they've got to think about what they know, explain why it's wrong. And on a similar note, you may have come across refutation texts. They're another example of this, getting students to really think about what they know and how their ideas have changed can really help with their learning and their understanding. This one is about a common misconception to do with Newton's laws. Reflective writing, this is on a bigger scale, getting them to think about their goals and motivation in science. So I've got some classes who at the start of the year were quite unmotivated. And so one of the things that I did at the start of the year was to get them to write me a letter. So I did some careful scaffolding and modeling of what I expected, and I basically gave them a list of the things I want to see in their letter, and we did it step by step. So the first step, I would like you to introduce yourself. I will introduce myself to you. I told them some things that I thought would be good for them to know about me as their teacher, and then I asked them to think, what would they like me to know as their teacher about them? I then have clear protocols. This is a kind of oracy strategy we use at our school. Nest means you're working independently, level 0 in silence, and the timing. Once they've done that, let's think about our values in science. We have science values in our school: precision, integrity, curiosity. Give some time for think, pair, share, some conversation to support it. Give them the definitions, and then ask them to think of a time that they have shown those values over the past year. And then give them time to write. So you can see the writing is preceded by the thinking, introducing new ideas, and oracy to scaffold and kind of support their thinking. So I found out some amazing things about my students. I found out some of the things they were worried about. I found out about some of the things that motivated them. I found out that some of them wanted to be astronauts. And especially at the moment when it's harder to get to know students who are new to you because of not being able to move around the classroom, this has given me a real insight and a way to help motivate my students, which helps them to learn better as well. I also then at the end of the half term, got them to do an end of half term reflection to think about how they are doing this half term, how they're showing our science values, and how to improve. So I think writing and this kind of reflective, almost journaling writing can be a useful tool for science teachers or any teachers to help with motivation for learning as well. And some of their answers are just really sweet. I've shown curiosity by thinking about every single question you ask me. So those were thinking about writing for learning and how to help with the understanding of science. I'm now going to think about writing for communication. This is, I think, the way in which most people think about writing in teaching is it's to tell us what you know, answer a question. So I think it's important to, first of all, be clear with students about the purpose of the different types of writing. And then writing frames, I won't go into much because I think that's a very common topic that you can read about, but then just show some examples of what I mean by analysing models, co-constructing success criteria, because that's one of the tools I find most powerful. And then thinking about how we can teach the planning process. So a bit like I showed with the storyboarding, showing other ways of doing this for different kinds of questions that students might be asked, especially as they get older. So first of all, the purpose of writing. So primary teachers teach students how to write all sorts of different texts. They learn about the different conventions from different texts. They can write all these different types of text by the end of year 6. So they are familiar with the idea of thinking about our audience. They're familiar with the idea of thinking about the genre we're writing in. So just to give you some examples of in primary, how I've thought about different genres and using science as a context for those genres and practice of those. Recounting, I did this with year 6 at the start of our electricity topic. Imagine a day without electricity. Do the same without friction, really get them to, you know, link what they're learning to what they're experiencing, but also think about their kind of communication, their practice of their writing. Procedural text, that's a really common one in science, writing up our methods and having lab books. But also there are a lot of cases where we learn about the history of science. We can imagine we are that scientist writing a letter about our discoveries and our evidence, our research. And also information texts are a great one to use in science. I make zines with my students quite a lot. So little mini magazines, and get them to write up information about the key topic. And on that note, I find that especially with students who are less keen to write, having a meaningful context can really motivate them. So for instance, with year 6, we were looking at light last half term, and I told them about Ruby, who wanted to make a shadow theatre, Little Red Riding Hood, but she accidentally cut out her wolf way too tiny. He can't be scary, so what can she do? She's run out of card. So we carried out an investigation to look at how we can change the size of shadows. And then again with writing frames, so this is something that, you know, this is a really common thing to use, but it's not, you know, don't forget about them just because they're common. They're really important to structure students, especially younger students, writing. Once they had carried out the investigation, they had really strong motivation to communicate their results because there was a reason that it was going to help someone out. So they then wrote their letters and linking their findings to helping Ruby out. Now, for all age students, but especially as they get older and the expectations of their writing in science and the conventions that they use become more specific, it's really important to look at models of good practice, but I also get them to look at bad examples and improve them. So this is an investigation I carried out with year 9 last half term. I did it as a demo because of COVID, melting ice cubes and looking to see whether we could reduce the rate of melting by wrapping them up in different materials. So I showed them a first method before they wrote up their own and said, right, if I gave you this as your instruction, would you know exactly what to do? And so I tried to, in my best panto silent demo teacher mode, demonstrate, and it was a mess. I didn't know what I was doing. And they were like, Miss, you've got to do this, you've got to do this. Okay, so what information is missing? So I then showed them method B. Right, how is this an improvement on the previous one? Discuss, how could it improve further? So getting them already to think, that's not good enough, miss, that's not enough information. And then method C, then thinking, okay, well, what in this method, which actually goes into more detail than you expected, what is there here that is useful? It helps us to see how our results are accurate and precise. So getting them to identify what makes a good piece of different types of writing. So this is for a procedural text, but you might do it for different kinds of texts, exam questions as well. And then creating success criteria. So from this, we made a list on the board of the things that made this a good method. And then I revealed the success criteria, which was neatly a summary of everything they'd suggested. Having gone through that process, rather than just giving them success criteria, means that they are meaningful, they understand them, and they can see why they need to do this. I've linked them again to our science values, being accurate, precise, showing integrity, and also, again, emphasizing the importance of redrafting. You know, would someone who missed the lesson be able to do exactly what I did if I gave them this method? So really being explicit about the reasons for the way that we do things. Planning scaffolds, this is a tool I used up to Key Stage 5. So when students approach longer answer questions, they often struggle with knowing how to begin or what the question is asking. So the steps, draw the process, write the keywords, and then look at the question. What's it asking? It's asking you to describe. Okay, so let's bullet point describe and explain, bullet point explain. And then we can use those points to write our answers. Another example, this is for year 10 energy, describe the energy changes. So we've got our diagram keywords and our description. Moving, they often see words and they don't realize that it's to do with motion, or they might see a question that's as this happens and not realize it's to do with time. So we need to practice and as a teacher explain how we link the question to what they want us to write. The next stage beyond that is, as people have mentioned, being explicit about logical connectives, because they're what allows us to then write sentences that make sense and show causal relationships. So by the end of the half term, my students were able to write a really succinct, clear, precise answer that had no waffle and actually answered the question. So final, I'm just going to whiz through a couple of points. Retrieval practice, I'm sure is a term it's familiar to people by now. The idea that we need to keep practicing things that we learned last lesson, previous lesson, half term, last year even, otherwise we're just going to forget it. Note-taking is really important for this to help students, and also thinking about ways to represent the information as we learn more about a topic and linking ideas together. So thinking about multiple representations, getting students to write, but also draw diagrams in their notes, modeling how we maybe make bullet point notes to start with, but then start thinking about questions. So the Cornell method of note-taking, there's lots of information online about it, but essentially you've got your key points and then your summary questions to really make you think about a text and help you if you want to do some self-checking later. Also thinking about, especially with younger students, how we structure their note-taking so that they're not filling in word gaps, but answering the sections and can see the key points as we teach them. And this is with older students, so these are my year 9s again. We have, again, success criteria for note-taking. Don't write down anything you don't understand. Add explanation, annotations, use diagrams, and write down summary questions as you go along. So they are getting practiced at this. They're writing things like, both are capitalized, so there are 2 elements. These are atoms, really showing on the paper all the things I'm explaining as I teach and model. And finally, mind maps. I use these for primary all the way up to 6th form, providing a structure that the students then fill in and we discuss to really make sure that we can see the connections between topics. So just to wrap up, I focused on the writing, but as I mentioned, this is all interconnected. And the one thing that you will have seen in my talk is that a lot of it is supported by oracy, by conversations I have, but conversations that students have with each other and listening to each other. And that's something that I'm aiming to develop in my practice. I'm working at a school that does a lot of work on this. And I'm hoping that one day I'll be able to give a talk that's like this, but about oracy. So some further reading, just to mention, these are things that have really influenced the way that I'm approaching what I'm doing with literacy. And the final thing I wanted to signpost is, if you've not come across the Institute of Physics online CPD, it's pretty great in my opinion. There's lots of free videos and online sessions, every half term a different topic. At the moment it's energy, so I'll make sure you've got the links in case you want any free physics CPD. But that's it for me.
Thank you so much for that, Carole. That was amazing. I really wish you were my science teacher when I was in school. Honestly, your lessons just seem so fun, so interesting, absolutely amazing. I really like as well how you kind of split your thought process to do with writing into like writing for learning, communication, and for remembering as well. I think that's really, really interesting. In terms of the half-term reflections, we just had a question. Have you seen an impact at all in the engagement of pupils using those half-term reflections? And have they added another dimension to kind of your planning and your thought process when you're planning lessons as well?
Absolutely. I think that's a really, really important thing is, you know, you can do a thing, but then if you don't think about the impact of it, then you don't know whether it was worth it. So I think one of the things for students is I really in the lessons talk explicitly about our science values. So for instance, precision, we are precise about the language that we use. We don't, you know, we're not vague. We need to, can we use a more scientific word? Can you say that in a more, you know, in a more clearly expressed way? And so what I've seen in some of their reflections is they're kind of identifying what they're doing that looks like precise. But then some of them are saying, I've noticed this, but I think maybe I could be more curious. Maybe I could try asking more questions this half term. So that's been nice to see as well, is they're not just seeing science as, you know, information that they're being given, but also something that they are participating in and something that is of interest to them, and they want it. It just seems to be quite motivating to them to have that space to think about it.
Oh, that's brilliant. Thank you. Yeah, and you're almost like teasing out the natural curiosity, aren't you, when it comes to approaching the lessons? It's really cool. We've had a question as well from Zainab. Do you think your approaches would work with upper A-level students? And if so, what approaches do you think would be particularly successful, those pupils?
Absolutely. So the kind of planning framework grid that I shared, I introduced because when I was in my first school, I had A-level students, all of them spoke English as a second language, and they really struggled with the longer writing questions. They had no idea how to approach them. They could do the maths, but the words, they just didn't even try out. And so I found that just helped them, give them the confidence, because rather than it being a big thing they had to do, it broke it down into smaller chunks. And I think especially with more mathematical sciences, having students who are confident with the maths and they've picked maybe physics because they're not confident with their writing, we need to appreciate that we really need to make it doable for them and break it down. I'd add as well, I love word of the week, word of the day. With my sixth formers, I would use words like, anthropomorphize or eloquent, thinking about not just the language of science, but introducing those words for them that they then want to use and they feel good using as well. So I definitely think basically all of that. I think as they get older, you remove more of the scaffolding and you're more metacognitive around, okay, well, what's my process? How would I answer this question? And you involve them more and more in the back and forth and put the burden of working it out as you go along more on them.
And increasing the challenge, for those older students. Yeah, absolutely brilliant. Thank you very much. And then we've got time for just one final question as well, Carole, if you don't mind. I thought about this myself as well, and I was watching your presentation. I really like the idea of tackling those misconceptions head on, not just in your explanations, but actually teaching them explicitly to the pupils. Have you found that particularly beneficial, and is it something that you do with every year group?
So I tried that for the first time this year because I've spent years trying to find ways to address misconceptions, and I came across the kind of post-it reflection I used to think, now I know, from Shirley Clark book, who's brilliant on formative assessment, mostly primary, but she's really great for secondary teachers too. And it made me think, the more explicit we are about it, the more you can actually, why are we pretending to kids like there's this secret misconceptions? Oh, we don't want to, actually saying to my attends, right, these are things that people get wrong about energy. There are a lot of them. Now I'm going to explain to you why all these are wrong, and you're going to be able to show me why they're wrong. And it's that kind of, it's about being explicit about it, and not treating them, you've got to treat them seriously. They are individual people who can take this information and use it, and it makes them feel really confident. I'll make purposeful mistakes at the start of a lesson and say, yes, this energy has been destroyed. And they're like, no, miss, energy can't be destroyed, no, miss. It creates quite some drama in the lessons when I drop in a misconception. They're like, no, miss, that's a misconception. And that just kind of reinforces and emphasizes. So I think especially with topics where there are some really deeply entrenched misconceptions, it's almost like, I don't know exactly what a metaphor is, but I want to say it's just like you need to like dig it out and destroy it, otherwise it will just keep resurfacing. Yeah,
that's absolutely awesome, Carole. Thank you so much for that. That makes total sense. And thank you again for your presentation and your Q&A. It was really insightful. So thank you very much. Really appreciate it.
You're so welcome. Thank you for inviting me.
Thanks, Carole. Right, onwards to our next presenter, Mr. David Gash. David is going to be talking to us today about evaluating his lessons using the Freya model. David's the head of science in a school in Liverpool and just an all-round good guy. And I've had the pleasure of working with David at the Seneca conference in summer, where he was talking about supporting building schema using sequencing and science. So I'm really looking forward to his presentation today. I think, have we still got Carole's screen share on? Carole, if you don't mind, would you mind taking down your screen share, please? Thank you so much. David can hop on. Thank you. Hi, David.
Hi, good afternoon. How are we?
Very well, thank you. Right, David, over to you. Thanks again for joining us this afternoon.
Thanks, Kieran, and thank you for the kind words. I don't think I've been referred to as a nice guy today yet, so that was a nice, reassuring start. Right, my name's David Gash. I am the head of science faculty at a brilliant school up in Liverpool called Gattaca School, and I'm going to be talking to you a little bit about my experience using the Freya model over the past 12 months or so. I do tend to be found lurking over on Twitter, so various Twitter links, Twitter handles, and blog information are on your screens at the moment. So in this talk today, I'm going to outline briefly the origins of the Freya model. I'm going to talk a little bit about my own experiences, what prompted this sudden interest, and how that's developed. I'm going to try and evaluate a little bit some of the pitfalls that I've encountered, some of the lessons learned, and finally, the longer term kind of impact on my departments. But I'm going to try and you know, spend most of this session with my teacher of science hat on, if I may. So this is Dorothy Freya. Now, I only learned more about the origins of the Freya model when I realized I was going to be doing this talk. I thought, well, actually, where did it come from? And it surprised me when I found out that actually the Freya model was created in 1969 by Dorothy Freya. Now, sadly, Dorothy passed away last year at the fantastic age of 80. But I did do a little bit of reading around her life, and she sounded like quite a remarkable woman. She's got a fantastic CV, be a bachelor's in chemistry, doctorate in educational psychology. And it was during her time at Wisconsin University where she come up with the graphic organizer of the Freya model. One of my favorite anecdotes that I come across when I was doing a bit more reading about Dorothy was from her nephew, who referred to her as a highly intelligent woman. So intelligent, in fact, that she would do the New York Times crossword in pen. So she certainly lived life on the edge. This is the Freya model. I'm assuming that most of you are familiar with it, the structure of it. So what I'm going to do is get straight into how I've used it in my lessons. So my interest stemmed from a visit from the wonderful Marcus Jones. So Marcus provided some whole school CPL. He come over from Huntington Research School around 14, 15 months ago. And he shared with us Alex Quigley's blog, The Confident Teacher. Again, I'm sure you're familiar with it. And within this, Alex talked about the impact the Freya model had on his science department. So this really got me thinking. I thought, right, I've been teaching 13 years now. I've heard loads about this Freya model. It's meant to be really good. Let's give it a try. So the questions that started to come to my mind was, well, if I'm going to use this in my science lessons, then what questions do I need to ask? How guided is it? Am I going to need to bring the students along with me? Do I give it them and let them get on with it? And is the time cost going to be worth it? I've done a bit of reading around, and it was one of the I don't want to say concerns, but one of the potential pitfalls is the amount of time that you do have to invest in this activity in your lesson if you use it. I also thought, is this going to throw up lots and lots of misconceptions, maybe more than I could actually deal with? At the time I was teaching a top set year 9, so I thought, right, great, they're coming on to a biology topic. Let's choose the word diffusion as the focus of our first Freya model venture. I armed them with mini whiteboards and an A5 copy of the Freya model graphic organizer. This is the graphic organizer that we decided to use at Gattaca. So you got your definition examples, non-examples, and your visuals illustrations. I asked the students to stick this into the book, and they wrote the word diffusion in the middle of the Freya model graphic organizer. Now, you'll notice in the top right, we've got visual/illustrations. In the original Freya model, I think this is listed as characteristics, but I thought this version of the Freya model could be really, really powerful within science, given the amount of abstract concepts that we come about, those that require things like the particle model and atomic structure diagrams to reinforce what the students are attempting to learn. So we decided to go with this particular model. So I said to the students, please write a definition of diffusion on your boards. And I instructed them to do this in silence. At this stage, I didn't want them to share any misconceptions that they had. You've just heard in the previous talk that actually getting misconceptions out is really powerful, really important, and I completely agree. But at this point, I want to know what's in each individual student's head. So I gave very clear instruction, write it down in silence. And then it was 3, 2, 1, show me. All boards fly up. And the responses were actually very mixed, which caught me off guard, to be honest. I thought, right, yeah, pretty safe word, diffusion, done it in year 7. These are bright students, shouldn't have any problems here. But no, it was really, really mixed. So after unpicking some of the wrong answers, shall we say, or the less correct answers, we agreed on a definition and we wrote it down live on the visualizer into the Freya model. So here we have it, the movement of particles from an area of high concentration to an area of low concentration. I then got me deodorant out, not because of stink, but because it's just one of your good pieces of kit that you have as a science teacher under your desk. You've got to have a tennis ball, you've got to have a magnet, you've got to have a spring, and you've got to have deodorant. I started to spray the deodorant and I thought, right, this is going to give the students that concrete example they need to retrieve this better than they have. I said to the students, raise your hand when you can smell the deodorant. Now, little caveat here, this was pre-COVID. So the students began to raise their hands. This led into a discussion of what was happening, and you could start to see the light bulbs coming on. My next step was to ask the students to suggest further examples of diffusion. Again, ask them to write them down on the whiteboards, but this time I was happy for the students to have some level of discussion. 3, 2, 1, show me followed. And what this actually yielded was lots of examples, but also non-examples. And it's in this where I felt that the Freya model really began to come to life. So we picked out some of the examples, discussed why they were good examples, and also some of the non-examples, some that were less right, or were maybe, you know, in an area that's linked to diffusion, such as active transport being against the concentration gradients rather than with it. And we agreed on 3 or 4 that we felt were most powerful and added them to our Freya model. All in all, this took around, visuals and illustrations. We went for the classic particle model diagram of diffusion. So particles close together, then further apart and spreading through the room. All in all, this took around 15 to 20 minutes of the lesson. So in terms of evaluating what happened and my next steps, I thought, well, the first thing was that short-term time cost. A lot of time went into unpicking one word, but actually the long-term gains for this were worth it, in my opinion. We've been able to unpick the particle model, make links to other areas within the same topic, active transport, for example. We've been able to ensure that the students know what diffusion is, and we've been able to give lots and lots of lovely examples. So in my opinion, it was most definitely worth the time invested. There's always the risk of sharing misconceptions, but in actual fact, this is about opportunities to uncover those misconceptions, to unpick them, deconstruct them, and then reconstruct that schema in the students' minds. And on that note, without the Freya model in this lesson, I would not have been able to uncover the lack of a retrieval as effectively. It does need to be carefully planned. But within that, there's opportunities for lots of careful planning and collaborative planning with your department. There's also the risk of lethal mutations. You know, there's a danger that this could turn out to be something that the students fill out. Well, it's not. It's actually a tool to guide student thinking. So ensuring that your staff, head department head on again, ensuring that your staff understand that actually it's there to guide thinking and not just something to be filled out is really, really important. So this led to much richer and deeper discussions on literacy, this very, very simple tool. We plan collaboratively anyway. We have a shared centre of teaching and learning resources, and it was a further platform to have those kinds of discussions within departments. Here's some very quick examples of other ones that have now appeared within our Key Stage 3 curriculum. These are not finished Freya models. These are simply partially completed templates that are there to provide a platform for further discussion with the students. Further impact is it's really supported subject knowledge enhancement. You know, getting the biologists to share with the physicists and the chemists some other examples of unicellular organisms, etc. It's really provided a fantastic platform for reinforcing our own subject knowledge. Our next steps will be to evaluate the words that we've selected. So we've chosen 1 word per topic in Key Stage 3. And over the next few months, we're going to use them, evaluate their effectiveness before deciding whether or not to continue using those specific words in our schemes. And hopefully try to evolve the model without succumbing to these lethal mutations. One of my colleagues shared an example with me this week where she's evolved this slightly to look at maybe a comparison. So exploring the etymology and the definitions of keywords, but on a side-by-side basis. So ensuring that any evolutions of graphic organizers are productive and are not detrimental. In summary, the Freya model is a wonderfully powerful tool for introducing, but also retrieving scientific literacy. A continuous cycle of planning and evaluation is critical to a success. Otherwise, you're going to run the risk of these lethal mutations. And finally, the choice of words are absolutely critical because it's that really rich discussion of your examples and non-examples that are going to lead to you being able to tease out to the students those misconceptions. So that's pretty much me. I think I'm just within time. I might get shouted at by Hannah in a second, we'll see. Feel free to hit me up on Twitter. I'm happily take any questions or unpick this further. My original blog post on this is linked on the screen, as is Alex Quigley's fantastic one on the Freya model too. And that's me. Thank you so much for having me. Have a fantastic day.
That's awesome. Thanks very much, Dave. That was an excellent presentation. Thank you. Really like those scaffolded Freya models, and I was laughing to myself about your secret teacher kit. We've all got one of them, but in more recent times, I'm sure we've all added anti-bac wipes, hand sanitizer, mask, gloves to that as well.
I'm thinking of getting a toolbox, to be honest, to put it all in.
No, you and me both. Yeah, that's awesome. Thank you so much. Next speaker, we've got Andy Markwick. Andy's going to be talking about deconstructing scientific vocabulary for low literacy students. Andy's worked in education for many years. He started as a teacher and now he is a university tutor for science education at IOE, and he's also an RSC member. And he's going to be talking to us today on behalf of the RSC. We were really, really lucky to work with Andy as part of our conversation series, chat on booklets, and you know, we're equally happy to have him today and really excited for his presentation. So it's over to you, Andy.
Thank you very much. Your introductions are quite amazing, you know that. It's great to be here with all of you and be part of this literacy conference. You know, I have been teaching for 34 years in schools, and when I started, it was pretty obvious that literacy was one of the main barriers to achievement with our students, and it still is. And so I think a conference like this, you know, really speaks for itself. I think it's so important. What I'm going to do over the next few minutes is just share with you some of the strategies that I've found, I suppose, most successful. Next slide, please. This is something that on, I suppose, face value doesn't look like literacy, but I think, you know, continuing from Carole's focus on oracy, it really is. Something I introduced some years ago was getting a debating society together in school where students didn't really see science as that important. It wasn't interesting to them. And I wanted to show them that actually science is really cool. And I invited colleagues from across the school, not just science, to talk about some of the things that interested them. So some of them, like, scientists can't believe in God, and, vaccination, which is, pretty hot at the moment. And invited on a voluntary basis students to come along and take part in the debates. I would also sort of try and suggest to those students that I thought needed to sort of develop their communication, their confidence to communicate, to also come along. And it really took off. This was done in the morning, and, by, I would say, the first term or so, we had 40 students regularly turning up. Now, this is important because students listen to each other, and by doing that, and listen to teachers and so on, and by debating, using sort of an evidence sort of base, they develop their argumentation skills, but also, probably more important than that, they develop metacognition. And of course, to be literate and be able to communicate, you do need metacognitive skills. Next one, please. Quite a bit has been said already about the importance of keywords, vocabulary in science. And this is something, I can't remember where I picked this up from. I really can't, but I've used it so many times. I think, the idea of understanding about tier 1, 2, and 3 words is absolutely critical for teachers, but also to share that with students. This is a sort of an alternative that I use, which works very well, where keywords are introduced as either objects, the nouns, the processes, or the concepts. And of course, sharing this with students is really important, so they know the sort of word it is. What are we expecting them to understand? For example, if we take the word evaporation, it's one word, but actually, to be able to conceptualize that properly, they need lots of other words. And once students can understand that our process words are actually really, they're just sort of defining a whole range of other words, it's a lot easier for them to understand. That's certainly what I found anyway, but we must share these with our students. It's interesting when I mentioned this to teachers and I asked something like, well, how many keywords do we actually give in each of our lessons? And it's anything from 4 to 8. But very often we don't think about what those keywords are and what we're really asking our students to develop. Next one, please. Now, this is something I think all of you have got access to an article that I wrote this year. I also did a similar one in primary science for the ASC, primary school students. It's all about the morphology of words, or etymology. And it came about because I really couldn't find a way of supporting my sort of low literacy, really sort of, kids with no confidence to answer examination questions. And you'd give out an examination paper and it would come back almost pristine, they'd look at it, they wouldn't be able to answer anything. Yet, if you spoke to the students about the particular questions, so oracy coming in again, they were much, much better at it, much better, and they could give you some sort of quite good answers. So I thought, well, how can I get around that? And I thought, well, maybe if I introduce and got students interested in prefixes and suffixes of, what we've been talking about in this session, of scientific words, maybe that would do the trick. Next slide, please. So this is something that I would do in the class, and it was consistent all the way through from, in this particular example, from year 10 right up until the end of year 11. And it really did seem to do the trick. What it meant, and the sort of little action research thing that I did, I could see that students were now being able to identify a tier 3 word, or usually, and understand what that meant, sort of reflect on, hang on a minute, exothermic. I remember that. I know something about it. And it would then encourage them to spend a bit of time on the examination question. And that, the sort of research I did on that, it showed that they improved their scores by about 34% by the end of the year, just by introducing this. I've also done the same thing with primary school students, because I teach in primary school as well. And the same thing happens there as well. And students love science words. They absolutely love them. Let's face it, what is there not to love about science words? Next one, please. Okay, so they're just, you know, some examples. There's lots of other examples that are in the article that you might, you know, find useful. One of the things I've always found very difficult, and students find difficult all the time, even now when I teach, I do a little bit, you know, in there, is understanding what we mean by describe and, you know, the difference between describe and explain. So over the years, what I've done is sort of put together lots of little activities where I ask students to first describe what they see or what someone is doing, a video, whatever it is, and then explain. And I found that if I'm quite consistent about this, it helps them to understand what's going on. And they eventually get the idea of what description really is. So in here, describe what you see. So they'll describe craters, they'll describe things like they are different sizes, they're all circular, but then to explain, why are they different sizes? So they start to sort of draw on their scientific knowledge to explain what they're seeing. And of course, you can really stretch students here because, you know, they're all different sizes, but if you look at the relationship between the large and the small craters, you'll see the smaller ones always are on top of the larger ones. So that's, you know, that's their description, that's their observation. But what is their explanation? And of course, that then draws on science knowledge again, and hopefully together you come up with an idea that possibly it could be to do with gravitational attraction and the mass, you know, the attraction between the masses of the meteor and then meteorite and of course the moon. So it develops all those sort of like ideas of thought. It develops their metacognition. I do this as a whole class activity. So people are listening to each other and they're developing these ideas. Now I've got lots of these. You can't just do this sort of a one-off thing. I've got lots of these different activities that have students describing and then explaining. And if you do it enough, believe me, the penny drops and students will get it. And then they don't feel so sort of alienated, I think, when they find these things in examination papers. So it's worth a thought, I thought. Okay, that is me done.
Fantastic, Andy. Thank you so much for that. I really, really appreciate you coming to talk this morning. It's something I completely agree with, and something myself that I've been looking at this year, the etymology and the morphology of, you know, scientific words. And really interesting what you were saying about how it's, you know, kind of getting people to really think about and reflect on the tier 3 vocab. And, you know, what a fantastic impact it's had with your pupils by the sounds of it. It's yeah, it's 34% improvement. You can't argue with results like that. Incredible. Thank you so much again. And we are thanks, Andy. And we are on to our final keynote speaker. Somebody really that doesn't need much of an introduction, but I'll try my best. So we're joined this afternoon by Mary Myatt. Mary's an education advisor, writer and speaker. Mary trained as an RE teacher and has worked with local authorities as an advisor and an inspector, and you know, written some absolutely incredible books on curriculum and school improvement, and recently created this amazing online CPD library called Soak. We're incredibly excited and honoured to have Mary speaking this afternoon, and really cannot wait to hear all about Mary's perspectives on developing the provision of science literacy. So without further ado, Mary, over to you.
That's a lovely welcome. Thank you very much indeed. Can I just check, Kieran, that people can see me, or you can see me and hear me? Absolutely perfect, Mary. Yeah, thank you. I have been known to speak into the void till someone's messaged me. Anyway, great to be here with you all. I've dipped in and out of some of them, just absolutely loving what you're doing, just brilliant work. I'm probably just going to be just putting just a few more examples in terms of what you've already been talking about. Andy's work, absolutely, that example of helping children to recognize the difference between describe and explain. My goodness, that's not just in science. That technique is so helpful, I think, across the curriculum. Dave's and others' work, it's just been great. And I know you've had Rose on earlier. I'm afraid I was talking to another one, but I know she would have been fantastic as well. I'm looking forward to catching up on the ones I had to miss. So 5 things I'm just going to just talk to in terms of literacy in science. I don't think this is going to apply to you actually, but I get an awful lot of people saying, well, why? You know, why should we be talking about literacy in subjects in general and science in particular? That is the domain of the English department or the literacy department in primary. But it's not. So one of the interesting things is that literacy has a unique status in our cognition, but also in the curriculum. And so unlike maths, so there was about 15 years or so ago when the strategies were in, there were national strategies. You're all too young to remember them, but some of us had to work with them. Anyway, there was a lot of talk about literacy across the curriculum, numeracy across the curriculum. It always struck me, and I'm sure it is the case, that literacy across the curriculum is something we can talk about in the way that we can't in the same way with mathematics or numeracy. So there are obviously links in mathematics with science, with geography, with art. You could probably shoehorn a bit of a few other subjects in there, but it doesn't have that foundational status that literacy does. And that is because we all communicate. So just that concerns me is that as a sector, we're obsessed with the written outcome because it's about this urge to evidence everything. And there's a feeling in many parts of the sector that I've only taught a lesson if there's been a written outcome. So it is no coincidence, I think, that in the English national curriculum, and I would argue across literacy and across the curriculum, including in science, is that writing is number 4. Writing's number 4. And we can only get some decent writing if children have been properly fed with the other 3. And quite often they're skated over because we're desperate to get to a written outcome. So there's some false levels of accountability that are going on there. And that's what I kind of want to unpick in this session. So let's just turn first to the speaking. Great quote here from James Britton, 1970, writing floats on a sea of talk. I can't write well unless I've spoken it. Now, it's not just in that instrumentalist way of thinking, you know, I've got to get the writing so that then they can talk. There's something bigger about the talk which allows children's ideas and responses to emerge, which is part, I believe, of respecting the dignity of the individual person and pupil in front of us, because we all have the right to express our views, but it also so happens that it supports the writing as well. David Crystal's work, vocabulary is a matter of word building as well as word using. So it's about building children's vocabulary, along the way playing with it, not in a mucking about way, but actually really digging deep, lingering longer with the beauty of language, and then being competent in using it. Now there's one school that takes this incredibly seriously, and I'm sure you're familiar with this school, and it's School 21 in Stratford. 3 to 19, so it's an all through school. The principles of their curriculum are head, heart, and hand. Head, heart, and hand. And so that's the intellect, the cognitive development of young people, the heart, that idea that we all have the urge to make a contribution to our communities and to society. So they have amazing projects that allow that to develop. And then hand. So how often do we provide opportunities for our children to create beautiful work? Quite often as artifacts, underpinned by the work of Ron Berger, The Ethic of Excellence. But, and this is the point, it's all powered through talk. It's all powered through talk. Why? Because they believe, School 21 believes, that oracy, the ability to speak well, is one of the biggest indicators of a child's success later in life. Now, if we just park talk and oracy in the English lessons, we're missing out on huge chunks of opportunities to develop this in children. I mean, they take this so seriously that in year 3, every child gives a 4-minute speech to an invited audience without notes. That's how seriously they take it. And, you know, sometimes, you know, I'm talking to people about the importance of talk and they say, well, I've got children in my class who are shy, so I don't want to put pressure on them. Well, it's my job to support children to talk and to express their ideas. I don't say to a child, oh, never mind, you're shy, you don't need to learn your times tables, or you don't need to learn to spell. You know, talk is as foundational as that. I was talking with a deputy head a while ago before COVID, and she said that they'd had a child at the school who had been in the care of the local authority, traumatizing background and consequences for the child's behavior. The social workers were so concerned about this child, they worried that they ever find a family to foster the child, let alone adopt him. Turns out the child was adopted, went to School 21, and she said the father sent her the 4-minute clip when this child was in year 3 giving his speech. So if a child with that level of trauma in their background can be supported to do that, then I think we've got an obligation to develop this aspect of our practice, so we're supporting all children. They have plenty to say. Oracy is reading together on the back of their work. They've got Voice 21, brilliant resources there, and also programs that colleagues can follow. And this is all the way through that you have this high quality talk. You can see, I'm not going to go into detail there now, but you can see the expectation that children explain their ideas, and you wonder then why they get great results. They don't do it to get great results. The great results follow from being very intentional about their way of working. Alex Quigley has been mentioned more than once, I think, on this conference. I'm just going to refer quickly to a great blog called ABC. I'll tweet about it later. Kieran, will you stop me if this has already been referenced? But one of the things that Alex suggests in his blog, and as we all know, he's written Closing the Vocabulary Gap, Closing the Reading Gap, masses of books on English literacy, and now works for the Education Endowment Foundation. But in this blog from a few years ago, he talks about developing questioning within classrooms that I just find so simple and so powerful. And it's ABC, as you can see there. So I ask a child a question, and so in my lesson, I do give them time to think, but for this, there's no hands up. I think, I'm not saying we ban hands up, but I think we've got to have some questions about when we allow hands to go up in lessons, because it tends to be the same children who have their hands up, whether it's primary or secondary. And quite often they're not listening to others. So they're not capitalizing on the learning, but it also gives plenty of opportunities for children to slide under the radar. So for the most part, I'd be saying no hands up, because I want to keep all the pupils and students in my class on their toes intellectually. And it means then I can call on any child for a response. However, not the child, obviously, where there's been some trauma grandma's died, I won't call on them, but otherwise everyone's fair game. So I ask a child a question, they give an answer. That's A, in full sentence using the subject-specific vocabulary, because we need to practice this. Now if that child can't answer, I go to the next child. If that child can answer, I then go back to the first child to repeat it. Why? Because they need the practice in the talk. However, if the next child can't answer it, neither can the next one, that's information to me. They haven't got it yet. I need to reteach that. But suppose they have, then I'm going to use B, which is to ask another child to build on what they've just heard. Same process. Then C, another child for another contribution or a contradiction, disagreeing with what they've heard before. Now, this slows the learning down, but you're building foundations. It means the children, we can cover more later when children are really secure in what it is that we're teaching them. Excuse me. So two things happen when I work in this way. One is I'm putting appropriate cognitive pressure onto the children in my class. They need that. It's good for them. It's a form of retrieval practice. Having to think what the answer is strengthens those neural pathways. But also I've got information about whether they're learning what I've taught them. Okay, so this slowing down is incredibly important. And I'm laboring this a bit because it seems to me that it's one of the neglected areas in the rush to make sure that we've covered everything in the lesson, that we're not falling behind. This is a mistake, in my view, to move on before I know that my children have learnt what I've taught them. Otherwise, we're saying that the plans are more important than the pupils in front of me, through what I call the curse of content coverage, the curse of content coverage. Now, I realize this is hard, particularly in science when there is so much to cover. But why would I continue covering if they haven't got what I'm trying to teach them at this point? Which is why I'm laboring it. Then listening. So my view is that children need teaching and training in the things that and behaviors that we want to see. Right. So I don't have time to go into it now, but I've done a lot of work from years ago and still use it in terms of training children to understand what deep listening looks and feels like, both from an affective point of view. We all know what it's like when someone's truly listening to what we say, but also from an effective point of view, if they're ignoring us. So I can tweet that out, or if you're adding links, I can add it over, the importance of listening. But also it's about learning. How am I going to learn if I don't listen? But they don't do it automatically. You know, children don't come to school knowing and being able to do everything and work in the ways that we know are most productive for learning. Think about it. If they did, we'd be out of a job, wouldn't we? So it's quite important. They can't do things that we can teach them. But there are a lot of assumptions made, particularly about speaking and listening, because you can't evidence it. But it's still important. Want to get great results, pay attention to this. Anyway, it's not about great results, but children having the opportunities for deep and wonderful and rich learning. Okay, now the next one is reading. Right, so this has got so much potential for deepening children's learning. I suspect it's already come up in one of the earlier sessions in any case. Here it's helpful to draw on Dan Willingham's insights that our brain's privilege story. Our brain's privilege story. Right. Now, when, so this is from Why Don't Students Like School, but from other sources as well. When we're talking about story, we're not just talking about novels and fairy tales and poetry, and I would argue picture books, but that's for another time. We're talking about high quality non-fiction texts. Right. So we want children to know more and remember more. This is one of the most efficient ways to do it. We've also got it here from Steven Pinker's work, world-renowned cognitive scientist, who says cognitive psychology has shown that The mind best understands facts when they're woven into a conceptual fabric, such as a narrative, mental map, or intuitive theory. Disconnected facts in the mind are like unlinked pages on the web. They might as well not exist, right? So it's really efficient selecting the right text to do this. Marianne Wolf's work, just take this quickly. She's written a lot, just an extract from Proust and the Squid, The Story and Science of the Reading Brain. Human beings invented reading only a few thousand years ago, and with this invention, we rearranged the very organization of our brain, which in turn expanded the ways we were able to think, which altered the intellectual evolution of our species. So essentially, reading makes us cleverer. However, there is a reading deficit across the sector. Right. First, in primary, a quarter of children don't reach the expected standard for the last year for which we have data. About only 30% of children are read to daily at home. Teacher Tap from a couple of years ago found that only 15% of Year 4 teachers read to their classes every day. I think this isn't have a go at Year 4 teachers, by the way. This is sector-wide. I think this is connected to the fact that a quarter of our children are not reaching the expected standards. We've also had this in the last month. The Oxford Language Report, in conjunction, in association with the Centre for Education and Youth, has found that there's a big deficit, particularly in transition. And so there's some urgency about this. It is very important. So we need to be reading more in schools across the curriculum. Fortunately, it's now sitting in the quality of education judgment. In the implementation bit, it is saying there's some narrative around the extent to which schools are developing and promoting reading across the school beyond English in secondary and literacy in primary. But there are some barriers, colleagues, which I'm just going to take quickly. So first is it's enjoyable. Now, as a sector, we're inclined to think if something's enjoyable, it can't be work, all right? But we've all had that experience, if we've read aloud to a class, whether it's primary or secondary, where it's what Claire Seeley calls the collective cuddle, right? That wonderful atmosphere in a class when this happens quite often. So there's something going on with us as professionals thinking, how can something so enjoyable be work? Well, it is, colleagues. The second is time. Two aspects to this. So one is that if I'm underpinning large parts of my curriculum with a text, a high quality text, how much time does it take me? It doesn't take that long, as long as I know where to look. All right. So again, and then I might identify some keywords that I want to emphasize, but what I'm not doing is working till midnight, preparing half a dozen differentiated worksheets that are going to widen gaps. So there's this notion of confusing activity with productivity. Sometimes some of the best ways of improving the impact for our children comes from thinking through carefully what we're doing, and providing this richness rather than just loads of activities. And then sometimes people say there isn't time in schools. Well, I think the evidence is saying that we ought to make time. Okay, third one, yeah, evidence. So someone comes into my classroom with a tick list, high accountability, either in their head, and what does it look as though the children are doing? Nothing. But it's all happening internally. So this goes back again to, we've got to evidence so much through writing. How writing is really important. I love writing, and I love children's writing, and I want them to write, but they've got to be fed first, is the argument I'm making. So a nice piece of research, which I mentioned on the session I was on this morning, and I refer to a lot. This is the Reading Aloud Faster Reading Research, came out of Sussex University. What they found was simply reading challenging, complex novels aloud and at a fast pace repositioned poorer readers as good readers, giving them a more engaged, uninterrupted reading experience over a sustained period. So the headlines of what happened in these schools, 2 novels were selected, at least a year above their pay grade, at least 2 years above what they'd normally be studying. That's all they did, colleagues, for 12 weeks. Not a huge study, but there's plenty more going on around this. 365 year 8s involved. What did they find? Mean progress for the whole cohort was 8.5 months. What did they find for the poorer readers, the low starters? Almost double that. So colleagues, I don't think we can afford to ignore this research, this evidence. And so for me, although this is year 8 English, I've got an obligation on myself with a background in religious education. How am I going to incorporate some of these insights into my practice? Because I can't afford to ignore these findings. Similarly, in primary as well. So we've got primary colleagues doing this as well. So why are they so important? And oh yes, now interesting, when they talked to the children about why they'd done so well, they said, the poorer readers, they said, we don't normally get the chance to do this sort of work. And we absolutely loved it. We found that we could get into the stories far more than we thought we could. And that made us want to do more. What do some of our poor, low power attaining children have? They have a diet too often in interventions of decoding, phonics, SPAG and leveled readers. And then we wonder why we have those awful results. Just give them this rich stuff. So stories are important on so many levels. And just a reminder, we're not just talking fairy stories. They provide the big picture. We know from Christine Council's work about the importance of the hinterland, complex ideas, enrich children's vocabulary because the written word is generally more sophisticated than everyday classroom talk. So you've got far more tier 2, tier 3, normalization, subject-specific vocab. And then as we've seen, they're inclusive for all. So sometimes people say to me, yeah, that's all right, Mary, but there aren't any subjects, there aren't any, that's all very well in English. There's high quality text, as I'm sure you all know, but it's not universally accepted yet across every part of the curriculum and every subject, including in maths. Children are asking for more demanding work, please. Human beings are curious, but thinking is hard. But children are saying they want more demanding work. This is being backed up by Willingham, and as we've seen in that Sussex research. So if we're thinking about the quality of education for all our children, not just in an Ofsted sense, we need to be asking ourselves if it's truly ambitious. If they're saying they like more demanding work, if learning is deeper, if they have more demanding work, the most efficient ways to do it, I'm arguing through a text. Just going to take these really quickly. Some science examples, absolutely gorgeous. You've probably come across some of them. So Charles Darwin on the origin of species, Sabina Radeva's work, fabulous stuff. Wonderful language in there, some misconceptions, very helpful, particularly in primary where might not have a science background. These are prompts for learning. That's a history one. Maths, so sometimes people say there's nothing in maths, but lots of schools are using extracts from Yuval Harari's Sapiens, A Brief History of Humankind. Some schools are reading 800 words minimum a lesson, including in science. Why? Because they understand the impact that this has. Talking to someone the other day, Ahmed Katab, we're recording an interview with him, and they read 800 words every lesson, minimum. Richard Feynman's 6 Easy Pieces, right? That arrived yesterday. I've included it. I'm sure some of you know it. It is so wonderful. Okay, so wonderful. Ben Rogers' work, Big Ideas in Physics, great science teacher. Carlo Rovelli as well, Brief Lessons on Physics. The most exquisite account of Einstein and relativity, you know, for someone who, you know, for whom this is new. It's just absolutely brilliant. The importance of concepts, very quickly. The lecturers holding baskets. It's the tier 3 vocabulary is generally sitting in there. Really useful if you can go, we can go into the etymology. That's already been mentioned by Andy, and I'm sure others as well. Sometimes people say this is too hard, and I say no, well, it's meant to be. That's what the cognitive science is showing us, and children are saying that they like doing hard work. But you know, how much deeper is children's learning if they know the root of the word isosceles comes from two Greek words, isos is equal and skeles is legs. They've got a bigger mental model. And we've got children at the age of 4 who are fluent in dinosaurs, haven't we? Some of those children also know that dinosaurs comes from the Greek word dinos is scary, saurus is lizard. So lots of opportunities for this etymological work. We just teach children how to do it in a browser, word etymology, plus the word plus etymology, it'll throw this up. Nice homework task, children will come back and tell us. The schools that are doing this, they're saying the greatest benefits are with the children with the greatest language deficit. When they talk to them, they say, we just really love finding this stuff out. It makes us feel clever. I think one of my jobs as a teacher is to make my children feel clever. They can be used on knowledge organizers, really, really unpacking these words. Never produce a knowledge organizer unless you're going to squeeze the juice out of it. So many ways to use them. Producing them and getting stuck in children's books, what a waste of time. So all the etymological work, low stakes quizzing, all the rest of it. These have already been referred to, these wonderful roots, Latin and Greek, lots of fun with these. So those are the 4 elements, colleagues, just about on time, I think. Speaking, listening, reading and writing, they all go together. Want to develop our children's cognitive faculties. This is what we need to do. I'm just going to reference a few texts. Isabel Becks and her colleagues, Bringing Words to Life, incredibly helpful in terms of vocab development. Really gets away from a keyword just being stuck on a board and we've done our job. This is about really bringing them to life, as she says. Already referenced closing the vocabulary gap, closing the reading gap, also very good from Alex. I just want to mention this one, just come out recently, Julia Strong and Pi Corbett, transforming learning across the curriculum from upper primary to 6th form. And, I've also got it here, it is absolutely fantastic. I think every school should have a copy because it includes science. So there's examples from primary science and secondary science. Groundbreaking stuff, just brilliant. So let's ask ourselves what adds greatest value, and let's remember, colleagues, that we're human beings first, we're professionals second. Don't let's bust a gut on this, let's just enjoy the process. That is going to get greater outcomes over time, and let's remember that our children are human beings first, they're learners second. Okay, colleagues, I hope that's helpful, and I'm happy to pause now to take some questions.
Hi, Mary. Thank you so much for that. That was absolutely fascinating and such a really nice message to end on as well, particularly surrounding talking about stories in science. Really, we want to open our pupils' eyes to the world around us, not just the content that they've got to learn for the exam. I completely agree as well with what you're saying about the reading ages. I read something the other day about the effect of COVID as well on reading ages of pupils. And I was just wondering your thoughts really on the kind of the pros and cons of reading aloud to pupils as opposed to asking them to read independently in the classroom.
Right, the most efficient way. Oh, do you mean what, we're all reading the same text independently or they're reading their own books?
Sorry, asking pupils to read a specific text independently as opposed to the teacher reading aloud to the pupils.
Right. David Dida's written really well about this. There, you know, in the faster reading research, it was a blend of the teacher reading aloud. That's how it started off with all of them. Then in some cases, the pupils read aloud, carefully selected by the teacher, where the teacher just went 1, 2, 3, you know, or children knew where it was coming. That appeared to create some stress, particularly for weaker readers. I think we've also got to be mindful that that was English. They had the text in school. So the units that I'm working up, we're doing, sometimes I'm buying a Kindle and I'm just taking some screenshots. I'm reading it aloud, or the way that I'm suggesting that's reading aloud. Probably just have an image, get the children listening as I'm talking, and then put the text up. then talk about the text. It could be photocopied bits of it up to the limit of 10%. So there's lots of ways of doing this. I think there's real mileage in just children just listening, because we know as a starter, but we know that children need to, any of us needs to hear a word 5 times before we're confident using it. This is long-standing research. Right, so you know, I'm going to be repeating a lot of this spaced repetition because if I choose the right text, it's not boring. I don't care if it's boring because it's good for them, but it's not. Rose is saying she uses a Kindle. Yeah, it's great for sharing text to pupils. Yeah, and some libraries offer ebooks to borrow as well. There's lots of ways of doing it.
Fantastic. So variety more than anything else, but I suppose kind of approach with caution if we're asking particular people to read out loud in class.
Yeah.
Excellent. Thank you, Mary. And just another one as well, you mentioned the importance of oracy, really, in developing oracy within the classroom. I was just wondering what particular strategies you've seen that are most effective to develop oracy within the classroom.
Well, actually, it's, you know, it goes back to that point. If we want children to be able to do something, we need lots of rehearsal. So there's a place for call and response. So if we've got a big word, lots of people are doing this. This isn't my unique strategy, but say the word, say the definition, children repeat it back lots and lots of times. Okay, so they're getting used to the speaking, which takes it into their DNA. I mean, I would go to, I mean, there's some lovely examples from one of the earlier sessions. Can't remember who it was now, but, you know, talking about the non-examples, talking about the deliberate mistakes, you know, this is, so it must be low threat. And then when we model mistakes deliberately, because that's good intellectual cognitive challenge, and we're setting ourselves up as being, you know, human as well. But I think, I just think it actually needs, it just needs us being far more intentional about it. So I would go to the Voice 21 materials first of all for this web. And the problem is it does slow it down initially. And so if we're in a school where we've got a pace means fast. Pace was never meant to be fast. Pace was always appropriate to the learning. So we will, I think there's quite a lot of work to be doing around that, which is why I think Voice 21 is such a great resource to turn to.
Fantastic. Thank you very much, Mary. And I completely agree. It's about being kind of intentional with what you're planning. It's develop those specific areas of focus. I just want to, on behalf of everyone as well, thank you again for presenting today. Thoroughly enjoyed it, and it was really, really insightful. So thank you so much.
Pleasure.
I'm just going to hand across to Tash and the rest of the Science and Practice team now, just to wrap us up for today.
Great, fantastic. Thank you to absolutely everyone today for such a fantastic eye-opening conference. I think it's safe to say that we have all learnt so much, and what an exciting morning that it has been. So just to end today's session, I would like to ask for some feedback from everyone that has been on the call. So as a committee, we are incredibly reflective, and we want to ensure that all future events can kind of share our key values, and that we hear back from you about what you found good and what you would like us to do in the future. So in the chat, I am going to now post a Google form. So if everyone could click on the link in the chat that I have just posted now and fill in this form, it should only take you about 5 minutes, but it would be absolutely fantastic to hear your feedback, and then we can collate it all together and plan some really great events in the future. Over to you, Hannah, to talk about some of these plans for collaboration.
Hello, thank you everybody for all of your input today and all of your talks. There's so much to think about from everything that we've heard. So for our future collaboration, we just wanted to mention those 3 values that Tasha was talking about. We are really aiming to be evidence informed. So if you feel like you have some really good evidence informed practice happening in your classroom, or if you're working on a project to become more evidence informed, we would love to hear from you and your progress and your findings. We are trying to be the most inclusive network we can be, so we want to make sure that this platform that we are building is leading to exposure for every teacher, whoever they are, whether they be very new in their profession, whether they have much more experience. Please do not be afraid to get in contact with us. We have lots of new opportunities coming up with lots of different platforms and ways to present, or ways to get engaged, or ways to lead workshops or to write blogs. And we want to hear from every teacher, because we believe our 3rd value is that collaboration is best when it comes to CPD and our practice. And we want to make sure that every person knows that they have got something to give, because we have learned from every person that has come to our events, whether it be an attendee or a speaker or someone that we're collaborating with. So it's absolutely vital that we just keep growing our network. So please, please, please just get in contact if you're interested. If you know that there's someone you're not to nominate because they'd be fantastic, send us messages. We would love to have a chat with every person, every science teacher, because it's all about making sure we share between ourselves so that our students can get the greatest impact and outcomes for themselves. So Fab, yeah, and then just Tash.
Yeah, so once we've collated all your feedback data and we have heard from you, so you either can reach out to us via email or DM us on Twitter, and then we will post our future events on Twitter. So make sure to give us a follow. I know lots of you will follow us already. That's @PracticeScience, and we will be tweeting plans for the new year and plans moving forward based on your feedback. So yeah, over to you, Hannah, to kind of conclude today's session.
So one thing we do here in the Science in Practice Network is we like to end every session, the 4 of us here, by sharing our key takeaways. So what we would love for you guys to do is share your key takeaways with us on Twitter. To make sure that we know it's a key takeaway, we would like to see a key emoji and 2 takeaway boxes. Tash will tweet out a tweet asking for your key takeaways with the right combination of like emojis. And please just send us your key takeaway from today. We would love to collate them. We would love to make sure that all of this feedback is taken on board so that we can move forward. And please, yeah, just stay in contact, keep an eye out on Twitter, because we'll be posting about different events that you want to see. We are driven by what we want as teachers, and we're driven by what other teachers want. So yeah, just keep in contact. And if you want to get involved, just contact us, because we want to grow and we want more people to have the absolute pleasure of working with the amazing people that we've got to work with this year. So thank you very much, and everybody have a lovely Saturday. Stay safe and enjoy your weekend.
Thank you, everyone. Bye.
Thank you. Bye.
Thank you very much, everyone.